Hey guys, welcome to Great Learning. Python is seeing a huge uptrend right now from the start of this year, right? Now, if you've clicked on this video, I am sure you're looking forward to learning and understanding some of the most important questions in Python that have the highest probability of being asked in your Python interviews, right? Since Python is a programming language which has a really vast scope, it becomes key that you actually spend a good amount of time preparing to tackle even the most challenging interviews that are out there. Now, keeping exactly this in mind, we here at Great Learning have come up with this comprehensively put together Python interview questions, right? We have 100 questions that should help you work towards acing your interviews and of course also help you towards getting to your goal as well. Now, the questions are broken down into three categories: beginner, advanced, and the most important part where we'll also be discussing are the tricky questions at the end of the session as well. So make sure you guys are watching this from the start all the way to the end to make sure that you're covering all the beginner questions, the advanced questions, and also the tricky questions, right? With this, guys, I know all of you all are super excited to get started with this. What are we waiting for? My name is Anirudh Rao. Let's get started. Since you're starting this video, you are clearly preparing for your dream job. So before we get started, I have something exciting for you. If you are finally a student or a fresh graduate with less than 1 year of job experience, Great Learning brings you this unique job readiness platform called Career Plus, where you can apply to 400 plus corporate hiring companies. Sounds exciting? Complete this video and check out our platform Career Plus, where you can quickly take a job eligibility test, pass it, and apply for the relevant jobs. If you do not score well, don't worry, we have your back. You can prepare from our specially designed courses and take the test again to improve your score before applying to jobs. More than 500,000 students from 2,000 plus top colleges chose us and secure jobs paying up to 10 lakhs per annum. So why wait? Check it out and join for free today.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleague, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.
Alright guys, so to talk to you about what it is that we're going to cover in this agenda, as I just mentioned as well in the Top Python Interview Questions 2021 edition, we are going to be covering 50 questions meant for beginners. Again, these are basic questions, but at the same time, these are also tricky and equally important even though you might be an advanced user, right? Once we cover the first 50 questions, we're going to be taking a look at 20 more questions. This is going to be slightly advanced, so if you're preparing for interviews where you have a couple of years of experience, this will help you a lot to progress, right? Now, regardless of beginners or the experienced users, the third section where we are discussing 30 tricky programs, right? This is where, be it you're a beginner or an advanced user, you'll have to pay a lot of attention because these tricky programs are the ones where people will stumble in a Python interview. Now, the goal of this video is to make sure you guys do not stumble on any tough question that might be asked in your interviews. That's the reason we present to you this 100 question list, and eventually all these questions not only consist of theory, but theory, practicals, and explanation that goes on to tell you about how the code works, why it works the way it does as well, right? So make sure you guys are watching the entire thing. Alright guys, on that note, we can get started with the first 50 questions, which are the beginner or the basic fundamental level. So what are we waiting for? Let's go with the beginner questions first. Alright guys, coming on to the first question now, we really have to start out this interview questions by talking about the key features of Python. Python is a very powerful programming language, and that is something which again the entire world accepts, right? So understanding what makes Python really powerful and popular is something you should know offhand. Now, here are some of the really interesting features that you may or may not know in case if you're preparing for an interview regarding Python, right? First of all, ladies and gentlemen, Python is absolutely free of cost, right? It's completely free to use, and of course, since it's free to use, it has to be open source, right? It gets contributions from all around the world. Now, take a look at the second line. We're saying that it's an object-oriented language. Well, of course, yes, Python treats all of its entities in the programming language as individual objects, classes, and so much more. So the entirety of support for object-oriented programming is there, and that is a huge advantage to Python, right? And of course, the third point should be attractive to all of you all right now, because Python is a fantastic language which is super easy to learn. It has amazingly clear syntax and really good readability. If you have to directly compare it with something like C++ or maybe Python, the syntax is so similar to English language in Python compared to C++ that you definitely feel like Python is the easier option, right? And of course, since we're talking about programming, we're talking about coding, writing code and fixing errors is going to be a process as well along the way. Now, with respect to debugging, you have to be really careful, and here again Python takes care of you, because as an interpreted programming language, Python is super easy to debug and work with, right? And if you think that's all the advantages are, look at the last point. Python talks to other programming languages like C++, Java, and it can work fantastically well in line with those particular programming languages, right? So you can have a combination of multiple programming language if you have an application or a requirement that asks for that, and of course eventually it will work as expected, right? So this is a very important question. Right. Now, coming on to talk a bit about Python, ladies and gentlemen, the next question states, what are keywords in Python? Now, keywords are a really important concept. These are the reserved words which are used for things such as identifiers, such as function names, and so much more, right? Now, you cannot use these words for your own usage. To be very clear, in Python right now, in the version of Python 3.7, and as and when the versions go on, they might add more and more keyword, but the generalized look on this is that we have 33 keywords here. Now, some of these keywords include the word false, none, true, break, if, else, return, continue, define as in def, right? So all of these keywords, these 33 keywords, you really cannot use it maybe for another purpose such as a variable. Maybe you want to create a list using the name, right? Now, I cannot have a name of a list or a tuple and call it true. It will absolutely not work, because those words are reserved. They have a separate meaning of their own, separate usage on their own, right? Now, guys, this is something really important that you should know about, right? You have to know that there are 33 keywords, and you will have to put out somewhere around 3 to 5 examples to showcase that you are familiar with these keywords as well, right? Yes, even function names cannot be used. Now, that is one thing I'm sure you would have thought about in your mind right now. Can I have a variable and call it print? Well, you cannot, because print has a completely different meaning, maybe than compared to what it is that you're trying to achieve as well, right? That you have to keep in your mind. Fantastic. Coming on to question number 3, what are literals in Python? Ladies and gentlemen, literals, again, as the name itself suggests, refers to all the data that we put in a variable or maybe a constant as well, right? Now, in Python, the interesting fact is that there are 4 types of literals. We have string literals, numeric literals, boolean literals, and of course, special literals as well. String literals is something as easy as my name. For example, my name is Anirudh Rao, right? If I just put it in a string format, well, that's a string literal on its own. Take a look at numerical literals, right? Now, numerical literal talks about numbers. We have integers, floating point, and complex numbers. Now, integer, an example is 1, 2, 3, 4, -1, -10, anything. For a float, we need the floating point number. So 3.14183263. Now, that is a floating point number. 1.9. That's a floating point number, right? And of course, we have complex numbers. Now, complex numbers will have one real part and an imaginary part. The imaginary part is usually denoted with an I. I'm sure you might have learned about it in school or your college, right? And of course, Boolean has to speak for itself, ladies and gentlemen. It's either yes or no, true or false, 0 or 1. It's always a binary outcome, and it is never anything apart from this, right? And special literals. Now, special literals also have a meaning to them, because if you take a look at an example, the word none, right? Now, you cannot just say even though having the word none may not make sense, but in some cases having the word none instead of leaving something empty or leaving something unattended is 100 times better. Right now, as a special literal, trust me, none is a fantastic one. And always whenever you're stating examples, make sure you try to state examples like this so that they know, the interviewer understands that you are proficient in all these concepts, right? Fantastic. Now let's move on to question number 4. Question number 4 states, how can you concatenate two tuples? Now, ladies and gentlemen, concatenate basically means to join two tuples, right? Now, we already should know what a tuple is at this moment of time. So I've given an example on your screen right now. We have two tuples, tuple 1 and tuple 2, right? Now, a simple operation of concatenation is to basically add a plus sign in between. Tuple 1 plus tuple 2 will give us an answer where all of these elements from tuple 1 and tuple 2 get combined one after the other and get appended, right? 2 gets appended to 1. Now, since we're talking about code, it always adds a ton of value to check all of these out practically, right? Now, throughout this entire interview sections, guys, we are going to be taking a look at a lot of programming concepts as well, because at the end of the day, since it's a programming language, you really need the expertise, right? Now, if you have your laptop and if you're sitting in front of an interviewer, it always is an advantage to quickly open up a Jupyter notebook and type in a small code snippet and showcase to the interviewer that it works, right? So let me quickly open up Google Colab. Now, Google Colab is basically my choice of Python Jupyter notebook, right? Now, you can have any other Jupyter notebook of your choice and it would still work, right? Fantastic. Now let me zoom in so that all of you all can see this, right? Ladies and gentlemen, this is question number 4. Question number 4, as we just discussed, is how do you concatenate two tuples? And as I told you, we have two tuples here, tuple 1 and tuple 2. Now, printing tuple 1 plus tuple 2 will basically have tuple 1 at the first and tuple 2 at the end, right? Look at this. This is from 1 and this is from 2. But what if I want to change the order? What if I want tuple 2 to come first and 1 to come later, right? It's a very simple thing. All you have to do is just put it in the particular order. Plus just uses it to append, right? Now let me just make this first one as a quick comment, and the second one, as you can see, says tuple 2 plus 1. Now as soon as I hit run, it should basically give me 4, 5, 6, 1, 8 true. Well, there we go. This is how simple it is to concatenate two tuples, right? You really don't have to break your head with respect to all the other methods or, so many different things that you can think of while having a very simple plus operator that does the task for you, right? Fantastic. Coming on to question number 5, ladies and gentlemen, question number 5 states, what are functions in Python? Now, functions in Python are really important because Python's popularity comes from the immense amount of libraries, functions, and these easy to work with tools and techniques that Python provides, right? Now, to talk about a function in itself, function basically is a block of code which is completely organized, and it ensures that if we ever need the logic that is present in this block of code, we can reuse it any number of times that we want, right? You can call it in different ways, you can send different parameters to it, and of course, it's just a same piece of code which will work maybe for 10 times. If you have written a logic to multiply two numbers, right, you don't have to do it every single time. Just have one function and just keep sending in 2 or 3 values, 4 values, 5 values. Well, hell, if you want to calculate the multiplication for 1000 numbers, you can do it with one click of your mouse button instead of writing and typing it out 1000 times. That is the most important thing about Python, right? First of all, we're shortening the code and reducing boilerplate. After that, we're also making sure that we're creating modularity in the programs. The program is being broken down into smaller understandable chunks. Now, if it's smaller understandable chunks, it is always an advantage regardless of the size of the program, right? So that is something you really have to think about. Well, and another good thing to answer while you're asked this question is to make sure to give 1 or 2 examples as well. Now, there are 2 types of functions in Python. We have the built-in functions and the user-defined functions. Give an example for a built-in function, right? Think of print. Print is a fantastically simple function. I'm pretty sure it'll be the first ever function you would have used when you're learning Python, right? Because we use that to type hello world, right? Now, that's a good example. Now, if you're talking about a user-defined function, what you can do is you can say, hey, we're going to use the word def, def, to actually define our own functions if required. Now, even though the question says what are functions, if you actually given a tiny detail such as this, the interviewer is definitely going going to be impressed, right? So guys, use this approach throughout as well. Now, coming to question number 6. Ladies and gentlemen, question number 6 states, how can you initialize a 5x5 NumPy array with only zeros? Now, I am sure at this moment of time, you would know how to initialize a regular 5x5 array, right? The two things you need to prepare for is the addition of maybe random values into it, or the latest trick question that is popular around the interviews is, how do you fill it with zeros? Now, to do this, you can actually do it a manual way and a fantastically easy way by making use of a function that NumPy provides called as zeros, right? Zeros is a function that gives the exact 5x5 output that you see on your screen right now on the right hand side, right? Now that we know this in a theoretical fashion, I think it's high time we take a look at this practically as well, right? Again, taking you back to Google Colab. Let me scroll down to question number 6, which was the one that we are discussing. Of course, since we're using NumPy, the first thing that we always have to do is make sure that we import the package in itself, right? Because if I comment this and if I've never imported NumPy previously in the Jupyter Notebook, I am actually going to get an error now, right? Look at that. It says that, hey, I cannot understand what it is that you're seeing because the function belongs to NumPy. Now let me change that back and hit play again, and now you will see that we have used np.zeros, and of course 5,5 denotes a 5x5 matrix, right? Now look at this. We have an entire NumPy array filled with zeros, and all we had to do was use this logic. That is it, right? It's as simple as that, but the question seems really complex to begin with, right? Fantastic. Now moving on to question number 7. Question number 7 is 100% going to be asked, ladies and gentlemen, because libraries such as NumPy and Pandas are literally the heart of Python. They are super popular. They are used in all of the different domains. So even though you might think that, hey, aren't Pandas and NumPy extremely popular for data science? Well, yes, they are. But at the end of the day, if you want access to really good two-dimensional data structures, Pandas and NumPy are brilliant. So what is Pandas? Well, Pandas has to be my favorite library in Python. It is again an open source library, which is of course free to use. It provides a ton of data structures for any database operations that we have. Now, the two really important data structures that will help you handle large amounts of files with a good amount of ease. You will never feel like you're handling a large file. That is because we have two data structures here, ladies and gentlemen. It's called series and it's called data frames. Now, series and data frames are absolutely fantastic. In fact, if you're solving a data science project, your data set can be a data frame. 99% of the time it's a data frame. If you want a single dimensional data base, a place to store your data, then you're going to be using Pandas series data type, right? Fantastic. Again, when you're asked what is Pandas, just don't tell them what it is. Just showcase that you know a little bit more about Pandas by talking about its data structures for a second as well, right? Fantastic. Now, as soon as you answer that question, there is a very good chance that the interviewer might ask you a follow-up question and say, okay, so what are data frames then? Well, now that you know that the question might arise, well, here is the answer to that, right? Data frames are basically mutable data types that are present in the Pandas library. Ladies and gentlemen, when I say mutable, you can change the data that is present in the same file, right? And of course, since we're talking about data frames, you can store any sort of heterogeneous data that you want. In fact, you can store multiple types of data, and it is super popular in the world of data science, as I just mentioned. Now, in data science, what we usually use to import a data set is this one beautiful function called read_CSV, right? Now, this is a Pandas function. So instead of just saying, hey, this is how we would do it, let us actually head to Google Colab and let us take a practical look at it, right? Now, if I run this, I am going to get an error. It's like, okay, where is this CSV file that you're trying to access? But what I will do is I'm going to upload it, right? Now, give me 1 second here. Let me just quickly go to files, data sets. I can have any data set that I want, ladies and gentlemen. I'm just opening one just to showcase for your reference as well, right? Now that that is uploaded, as soon as I rerun this tiny piece of code, now it gives us an output, right? Let me zoom out a little. Now, look at this. This is basically us printing out, us importing the data set and us printing out the first 5 rows. Now we'll have another question where we're talking about head, but for now you have to understand that the default parameter for head is basically how many rows. Well, you can go on to guess it because it's actually 5 rows as well, right? So if you want, now you might be saying, hey, I want 12 rows to be printed. Well, pass the argument 12, and at the end of it you can see that 12 rows 0 to 11 are printed for you as well, right? So this is literally as easy as this, ladies and gentlemen. Fantastic. Now that we're done with data frames, let's take a look at pandas series. This question can be asked in the reverse order as well, right? If you mention series and data frames instead of data frames and series, they might just ask in the same order. So let's cover basis on these two and let's ensure that we are clear with this concept, right? Now, a series is different from a data frame because the series only provides support for one-dimensional data structure storage. Now, when this is of the type that it's a one-dimensional data only, there could be a question that says, hey, isn't it inefficient? Well, it's not the talk about inefficient. If your project only requires you to have a data structure unit which would support one-dimensional data, why would you want to complicate things with a data frame, right? So with, again, pandas series and both data frame supports multiple different operations, and it is extremely popular for a single dimensional data. So if they ask you a question saying for single dimensional data, would you pick series or data frames? At the end of the day, you can pick both, but the most popular one, the simple one, the hammer on the nail is basically series, right? So make sure to answer it that way. And now, of course, we have to take a look at series. So let me quickly scroll down to this particular part. Now let me zoom in a little. Right now, ladies and gentlemen, what is a panda series? We just check this out. The first line has to be import because without this, you know that we're going to get an error, right? Now, look at this. We have a couple of elements here in data 1, 2, 3, and 4. Now, 2 of these are numbers. This is an integer, this is a string, this is a string, and this is a floating point value, right? Now, what are we trying to do here is basically create a series out of this particular data, and eventually we're going to print out the series after creating it. And to verify that it's been done, we're also going to use the type function to print what type it is. It's supposed to say series there, right? Now, as you can see, 0, 1, 1, 2, 2, 3, 3, 4. Fantastic. It works. 0, 1, 2, 3 is basically the order. It's an index. 1, 2, 3, and 4 is what we require. This is a string. This is a string. These two are integers, right? Now, take a look at this particular thing. It says class core series.series. Now, what this is telling me is that, hey, we took data and we basically made a series data structure out of it. And yes, as you can see, this is one-dimensional data, right? Fantastic, guys. Now, let's quickly take a look at the next question, the 10th question, that states, what is the use of pandas group by function? Now, the group by function in pandas is super popular because it will give you the functionality of splitting and grouping together an object. This is a very common operation that you will be performing a lot if you're working hands-on with a lot of data, right? Similar to like SQL, MySQL, be it the entire working of even Oracle group by. Now, MySQL is a part of Oracle, of course. So how the SQL group by statement works, right? It basically groups the data by its classes and entities, which eventually you can use later for any sort of convenience that you would want. And that is one advantage, having the functionality in Python to achieve something that SQL does in a fantastic way, in a structured way, is what we are looking after, right? So let's actually head back and take a look at what is the use of pandas here, right? Now, ladies and gentlemen, I have a data frame in front of you. pd.dataframe is the syntax to have a data frame. In this data frame, we have two entities. One, we've called it as vehicles, as in we have car manufacturing companies and a couple of bikes as well. We know Kia is famous, Lamborghini, KTM RC390 is a bike, Pulsar 200NS is a bike as well. Now, what type are these vehicles, right? So, Kia is a car, Lamborghini is a car, and of course KTM and Pulsar are the motorcycles, right? Now let me go on to print this. Using just this clause of where we have given it a type, you can see that we have grouped it with respect to the names. But have we used the group by function here? Well, we haven't, right? Where did we use it? We just created the data frame and created two dimensions in it, right? Now, where is it? Well, look at this next line. I just wanted to execute it previously to show you the difference as well, right? Now, after you execute the group by statement, ladies and gentlemen, take a look at this, right? It says, hey, there are two cars and two motorcycles based on the type, right? If I asked a question saying, hey, I want to group by all of these details in my SQL table, and I wanted to be grouped by type. I want all the bikes on one side, I want all the cars on one side. Now that is literally what we did using pandas, and in a fantastic way, right? Look at this. This is basically one single line of code that does what a complete SQL query would do for us. That, ladies and gentlemen, is the magic of Python, right? Fantastic. Now coming to the 11th question. The 11th question states how to create a data frame from lists, right? We know how to create lists. We know how to create data frames, but can we create a data frame from a list? Now that could also be the way the question can be framed as well. The first answer, can you create? Of course, yes, we can create. Okay, next is how do we do it? Well, we simply take an empty data frame and we add the lists as individual columns in the data frame, and we are done, right? You're going to require a list, you're going to require an empty data frame, and eventually you're going to be adding all the elements of the list to the empty data frame in the individual columnar form. That is all that it takes. 2 steps, right? Let's check this out practically. Now, as you can see, we are creating an empty data frame. And of course, we have lists here. One states bikes, Bajaj, TVS, Honda, Kawasaki, and BMW. And of course, we have the cars as well. Lamborghini, Maserati, Ferrari, Hyundai, and Ford, right? These 2 are the list. Now, here is where all the magic is happening, ladies and gentlemen. DF of cars equal to cars and bikes equal to bikes. All we're trying to do here is to take the list, put it in the form of columns. The name of the columns is going to be cars and bikes. And as soon as I go on to print the data frame right now, you can see that cars and bikes, we have 2 columns of data, and all the cars are on one side, all the bikes are on another side, right? So we took 2 lists, we put it out into 2 columns, and we created a fantastic data frame. And the heart of the logic, the core of the logic of how to do this is literally in one line, right? Now this is the line that converts it, but to do this, you're going to need an empty data frame, and of course you're going to require all the lists that you're actually going to use, right? Fantastic. Now let me actually go back and take a look at the 12th question. The 12th question is a very interesting one. It's how do you create a data frame from a dictionary? Now, ladies and gentlemen, this is going to be a follow-up question if you start getting quizzed on data frames a lot, right? Because the interviewers definitely want to understand your proficiency on the matter here. Now, how do you create data frames from a dictionary can also be asked as, can you create a data frame from a dictionary? Now you know the answer to it even before answering this particular question is that yes, you can convert data frames and have it converted from a dictionary. Now, how do you actually do this is very simple. Take the dictionary, pass it as an argument to the data frame, and you are done. You would have created a data frame with all the details from a dictionary, right? Again, it's 2 lines of very simple logic. So let's actually check it out. We have an empty data frame. We already saw this. We have 2 lists. We also saw this. Now, the magic is happening in these 2 lines, right? All we're trying to do is basically take the details from the dictionary. Now, this is the dictionary of us, right? We have this. This is the dictionary. But what is our requirement? Do not give us a dictionary output, but convert the dictionary and create a data frame. That is what we've done in this particular line. Of course, the last line just is printing the data frame here, right? Again, take a look at this. We have 2 lists, we have a dictionary, and all the data to the dictionary is coming from the list. However, our final result is what? It's a data frame that has all of these values, right? So ladies and gentlemen, this is the heart of the logic. And whenever you ask these questions in the interview itself, you can quickly type up 1 or 2 lines of code and say, hey, instead of me writing it out on a paper, here, let me demonstrate how it works for you, right? That in a Python interview is super impressive, ladies and gentlemen. All right, fantastic. Now that we're done with 12, let's come to question number 13. Question number 13 states how to combine data frames using the join function. Now, the join function is a friend in Python because we're going to be using a lot of join functions. If we're working on any sort of data science projects, if we're working on even a good amount of web development as well. So regardless of what domain, it's a popular one. So make sure you're paying attention. As the name itself suggests, basically join functions are nothing but data extraction entities which will help us access multiple different data frames which has more than 1 or more columns, right? Basically, it can have 1 column as a common data between 2 data frames, or it can be that 5 columns are actually identical and you just want to combine them and join them using those columns as a header, right? Just like how we would do it in SQL. Now that is possible, but one thing you really have to understand here is that the stacking when the data goes on, right, it is horizontal. It is a horizontal stacking if join function is used. And of course, with respect to pandas, you can do a left join, inner join, a right join, and even an outer join as well, right? So whenever you're asked how to combine data frames using join, make sure you're talking about the process of how it's done, talking about that it's a horizontal stacking that's being done, and of course, what are the types of joins that pandas support us, right? These three are the foundational points that you guys have to say. So I hope we're clear with this. But that's fantastic. Now, once you say the word horizontal stacking, there's a good chance that the interviewer might be curious to say, okay, this person knows about stacking, so he or she can know vertical stacking as well. So you might be asked a question saying, okay, so which method works best if we are taking a look at vertical stacking of these data frames, right? Now, for vertical stacking, instead of the join method, we have another fantastic method which will work beautifully well. It is the concat method, right? Concat method again will work well when you have data frames which have the same columns and you're trying to concatenate them using these similar fields as well. Now, what kind of stacking did I say we're going to be using for concat? Well, we're trying to use vertical stacking, right? It takes up multiple data frames, vertically stacks it, creates one single data frame for us. So question number 13 and 14 are actually linked together and they are very important at the same time, guys. So make sure you answer it that way, right? Fantastic. Coming on to question number 15. Question number 15 states how to merge data frames in pandas. Now, this is very, very important because in pandas, you might have created multiple different data frames down the line, and there will come a time where you might have to combine them or you might have to merge them into one, right? How do you do that? Well, merging depends on a lot of things. First of all, on the types and the fields, right? Now, if you're trying to merge two separate data frames, it's going to have data that might not be the native one in each. It can be two unique pieces of data that are being merged, right? So if the fields are actually similar, what happens is that the data gets merged in the axis 0. The first axis basically, and then if the fields are different, well, it just moves to another axis and creates one more axis. They are merged along the axis 1 to ensure that readability exists, right? We're not trying to merge and sort of randomly mix everything and shake things up. No, we are trying to find the most structured way of how we can merge these data frames to see if all the similar fields can be accessed at once, and of course all the fields which are different to each other, they'll be merged on a different axis, so you have clarity when you're reading about it, right? Fantastic. Coming on to question number 16. Question number 16 is an interesting one because it says, hey, given the below data frame, how do you drop all the rows that has NaN? Now, NaN, or it's also called as NaN, basically stands for not a number, right? Now, that is also an important entity that is present in Python. Now, if we consider the data frame, how would we go on to use it? As you might have guessed it at this moment of time, there is a function that does exactly this. The function is called drop NA, as in NA stands for not a. For some reason, it doesn't drop NaN, it is drop NA, right? This is a pandas function. So if you're ever using it, make sure that you are importing the pandas as well, right? It's a very simple piece of code. Look at this. This is what the input would look like. You can see that there is the presence of NaN values here. This is what the output looks like, and there is no NaN values there. Absolutely fantastic, right? We don't have to type in 10 lines of code to do this for us. We don't have to type in 2 lines of code to do this for us. All you have to do is import pandas, use the function, and you're good to go, right? Superb, guys. Coming to question number 17. It states how to access the first 5 and the last 5 elements of a data frame. Now, that's a tricky question, right? They're asking you to access the first 5 elements and the last 5 elements as well. Now, do not worry, this is a very simple one to do. There are again 2 functions to do this. We already checked out one function, which is the head function, right? Head function prints the first 5 rows. You can see that head of 5. You remember when we imported the data set? This is exactly what we were doing there. Okay, fantastic. We know the head function works, but what about the tail function? What does it do? Well, tail function basically, instead of providing all the printing all the details about your data frame from the first to last, well, the tail function prints it from last to first, right? So if I say tail of 5, I'm just getting the last 5 elements. If I say head of 5, I'm getting the first 5 elements. Now let's quickly take a look at how this works, right? Again, as you can see, we're using the same CSV file that we have previously imported, and it should still be since we have it should still be there since we haven't disconnected. Now, as soon as I run this, head of 5 will basically give us the first 5. Now, you might say, how do I know that this is the first 5? Well, look at the ID column, right? ID, again, it's starting with 0, 1, 2, 3, 4, 5. Of course, it has to be the first one. Now, what are we going to do? Next, let's take a look at the last 5 rows using the tail function. All the other logic remains the same. Now look at it. Now look at this ID column, ladies and gentlemen. Here you can see that it's 751, 752, 755. Now, since Python starts indexing from 0, I can guess that this data set has 756 elements. And of course, these are the last 5 that's printed for us. Now, if I want last 3, just change 5 to 3, hit that button, and you are good to go, right? Look at that. We got the last 3 as well. So simple. Head and tail. Make sure you're answering it that way as well, right? Super, fantastic. Let's move on to question number 18 now. Question number 18 says how to access data from a data frame using a value as an index, right? Now we know that with respect to data frames, it is index positions, as in you can go into a data frame, access one particular element that is present in a two-dimensional space, change it around and work with it, right? Well, of course we can do it. To do this actually, to how we can go on to access the data with respect to using a value as an index is very simple, ladies and gentlemen. We're going to be using one particular function called lock, right? LOC. Now let's actually take a look at it practically so that you guys understand it, right? Now importing pandas is straightforward. Having tool list is also straightforward. Dictionary, we already checked this out. We converted it to a data frame previously as well, right? Now look at this part. A equal to 10, 20, 30, 40, 50 and df.index equal to A. So I'm telling that, hey, for indexing this particular data frame, use all the data that is present here. And of course, as I told you, you have to use lock, right? Now, if I say lock of 10, what it's basically trying to do is tell me that, hey, okay, now the indexing is considered from this one. What is the first one? Bajaj and Lamborghini. Now, what is the name, the index that is associated with these first position elements? Well, what is it? It's going to be the first one here. Alright guys, now that we're clear with this, let's actually get back to take a look at the next question, which is the 19th question, right? Now the 19th question states, how do you add single line and multi-line comments in Python? Of course, everyone might know at this moment of time how to add single line comments, but did you know how to add multi-line comments? It is pretty simple and straightforward, guys. With a single line comment, all you have to use is hash. If you've ever used Instagram and all the other social media tools, you would have known the hashtag madness, right? Well, the hashtag madness in Python is a dear helper because a single hash mark denotes that it's going to be a comment, right? That entire line to the right of the hash is going to be a comment. But that's a single line. What about multi-line? Well, multi-line is even more simpler. All you have to do is open triple quotes, as in you have to open quotes 3 times, right? Double quotes 3 times, as you can see here. 1, 2, 3, and just have any number of lines you want and just close it back again. So everything that is enclosed between these triple quotes is nothing but a multi-line comment, right? Let's take a look at that now. Right guys, as you can see, this is a single line comment, right? Now this literally is a comment that you see in green color right now. This line Python will not execute because it knows that it's a comment. Now what if I just use hash and type in something like Anirudh Rao here, right? Is that a comment? Absolutely not, right? Look at that. I haven't even done anything and it's giving me a warning out there. Now, what I'm going to do is basically run this particular comment. Now, you can see that this is not a comment, but still it has a hash there. What's going on? As I told you, everything to the right of that hash on the same line is a comment, but everything to the left of it necessarily need not be a comment. Look at this. This is a multi-line comment. Triple quote open, triple quote close. So everything that is present in between this is a multi-line comment, right? Now, as soon as I print it, it should say, hey, this is not a comment because we're trying to print this. And at the last line, it says it's that simple. Well, ladies and gentlemen, it really is that simple, as you can take a look at it, right? Fantastic. Let's discuss question number 20. So what is the most memory efficient way to add elements to a tuple? Well, what is the most memory efficient way? Now, you might be thinking about 2 or 3 different ways, but do not fall for the question because this is a trick question, ladies and gentlemen. Tuples in Python are absolutely immutable. When I say immutable, you cannot add data to an existing tuple. If you want to add new data, what do? It's simple and straightforward. Create a new tuple for it. If you already have a tuple and if someone asks you how do you add, how do you modify or something like that, understand that it's a trick question, right? Be very careful with questions like this. They get thrown right in the middle of the conversation and they'll try to catch you off guard. Now, if you were to answer these, then the interviewer is going to be confused saying, hey, does this person know Python to a good amount of detail, right? Be very, very, very careful. And, I have a lot of trick questions that we're going to be covering, but this is an important one. And talking to a lot of professionals, this is a question which again is super popular in the year 2021. It's moving around the interviews a lot, right? Fantastic. Now, coming on to question number 21. Question number 21 states, what is a dictionary in Python? Okay, so what is a dictionary in Python? We've already used dictionaries, right? Dictionary is a fantastic data type in Python where we can have collections of items without having any sort of order. So it's an unordered collection of items. That is literally what a dictionary means. But when you're answering the question, make sure to give a little more details about it. For example, you're going to be using curly braces and there's going to be 2 elements for a dictionary, right? One is going to be the key value and the other one will be the value itself. Now, the value gets mapped on to each different key. So there's multiple keys for multiple values out there. One key, one value, another key, another value, right? That you have to answer. And of course, it is always efficient if you guys give one example as well, right? Now, if you don't have an access to a laptop while you're giving your interview or anything as such, take a piece of paper and just write down an example such as this, right? Now, here you can see the key values specifically, right? We have 2 keys and we have 2 values, key, value, key, value. It is as simple and as straightforward as this, guys. Don't just say it's a collection of unordered element. Make sure you're breaking it modularly down into these 3 or 4 important points and mention that as well. Alright, coming to question number 22. Question number 22 states, find out the measures of central tendency for this NumPy array, and you have a sample array on your screen. Measures of central tendency. Well, we have heard it somewhere in our school or colleges, and it might be a little hard to recollect in the heat of an interview, but understand that central tendency is nothing but mean, median, and mode. Right? It is as straightforward as that. In fact, when you're asked this particular question, you can give a bonus answer to the interviewer itself saying, hey, I can give you the mean, median, and let me also give you the standard deviation as well, right? Standard deviation talks about how individual values varies from the mean of that particular data, right? That is standard deviation. You don't have to implement anything manually because there's functions for everything. Mean has a function, median has a function, standard deviation also has a function, right? Again, a quick demo. So let's take a look at this. Let me scroll down to question 22, and as you can see, we're using NumPy. So I don't have to do this all the time, but since you guys might be learning this, and if I skip this, there's a very good chance you might get stuck on an error in the heat of the moment, right? So I'm making sure I'm importing multiple times. You don't have to do it, however, right? Now look at this. We have taken the NumPy array that's been given, right? Now they've given one more array. Here we have another simple array as well, right? If you want the exact same one, well, we can actually go on to have this as well. Done, right? Now, as you can see, np.mean, np.median, np.std, which is the standard deviation. And all we're trying to do is pass the array as a parameter, and we're going to get all the values of that, right? Look at that. This is the mean value of this entire array. Now, the median value is 5 and the standard deviation is 34, right? Now, this is an important thing. And as you saw, it is again simple. One line of code. It's not even 10 characters, ladies and gentlemen. Python lets you do so much for so little. This is the magic of Python, right? I hope we are clear with this. Let's get back to the next question, which states, what is the use of a classifier? Now, again, this is a question that will eventually see itself asked, randomly, or while you're thinking about something else, the interviewer might just throw this in and ask you this particular question, right? Now, what is a classifier? The question, is pretty simple here, and the answer even remains in the question itself. With a classifier classifies something. So what are we trying to classify? Here we're trying to predict the class of any particular data point that we have at hand, right? Classifiers can be considered as special hypotheses, basically, which are used to assign class labels. And where are we assigning these class labels, right? We want certain data points to bring class labels, data points together. That is why we require a classifier. But classifiers are popularly also used in the case of training the data in the machine learning application, where you're trying to even understand the relationship that exists between a class of variables and the individual variables themselves. So instead of just saying a classifier is used to classify special hypotheses, make sure you're paying attention to the third point and make sure you state that, because classifiers are exactly used for that purpose. And if you state the purpose, it's again a hammer on the nail, a perfect answer, right? Fantastic, guys. Let's take a look at question number 24 now. Question number 24 states, how do you convert a string into lowercase using Python? How do we convert a string into lowercase? Do we have to manually do it? Again, the answer is no. You have a function to do it for you. This time we have a string function. The function is called .lower, string.lower, where you can have any string there, right? Look at the example on your screen. We have a string which is completely in caps, which has great learning, all in caps. And as soon as I print another statement, of course this can be in the next line as well, print string.lower, right? And all it's going to do is any character which is not in lowercase, it will compulsorily bring it to lowercase. But you might ask a question saying, but what if it is already lowercase? If it is already lowercase, it is ignored. But if it is not, it is forcefully converted into lowercase, right? Fantastic, guys. Let's take a look at question number 25. Question number 25 states, how do you get a list of all the keys that are present in a dictionary? Now remember, when we spoke about a dictionary, we spoke about keys. We spoke about values for those keys. Now the question that's being asked is, can you create a list of just all the keys that are present in a sample dictionary? First of all, it might be a question that is asked saying, can you do it? Now the answer to can you do it is yes. If you say yes, the next question is going to be, how do you do it? That's what we're taking a look at, right? Here again, we can get a list of keys. There's a simple function called dictionaries.keys, dig.keys basically, wherein it will give you all the keys, right? This method will return every single key that is available in that particular dictionary. Now I know it's going to add a lot of value if I show this to you guys practically. So let's take a look at it. Again, it's 2 lines of code. Look at this. We have one dictionary where we have the keys and the values associated with it, and I just run the .keys function on this particular dictionary. That's why it says dict.keys, right? Now dict.keys basically is going to give us an output 1, 2, 3. Now 1, 2, 3 are what? This is the key. 1 is the key, 2 is the key, 3 is the key, but A is the value associated with 1, B is the value associated with key 2, C is the value associated with 3, right? Pretty simple and pretty straightforward. Fantastic. Ladies and gentlemen, let's go to question number 26 now. Question number 26 states, how can you capitalize the first letter of a string? How do you capitalize just the first letter of a string, right? Now we saw that we can take the entire thing to uppercase and maybe the entire thing to lowercase as well. It works both ways. There are 2 functions, right? Now to just capitalize the first word, the answer lies in the question itself, capitalize. There is a function in Python called capitalize, which will just take the first character of a string and just make it into uppercase, right? But again, a question that might be asked to you at this moment of time is, okay, so what if it is already a capital letter to begin with? If it is already a capital letter to begin with, you have reduced Python's job and it will just ignore it and say, oh, okay, so this is already capital. Let me move on. Right? That is it. Let's take a look at this practically. And again, it's a simple 2-liner piece of code here, right? Now, n equal to great learning. As you can see, I have a lowercase for G here. But as soon as I run this piece of code, n dot capitalize. Now, capitalize is the method I was talking about. Look at this, right? The first character of the entire string has been made into caps. Of course, this will work for anything, ladies and gentlemen. You can have, for example, let's do this. Let's just say that there is a typo, right? The first name is not in caps. Now, as soon as I run this, it will be the perfect form. A is going to be in caps. And of course, take a look at this. Now, the R capitalize has also inverted, right? Now, I want you guys to head to the comment section and tell me why this particular thing happened, right? Capitalize basically does the other thing as well. Now, okay, so now that you might be asking about it, let me do this. Now, what happens if I do that? Well, if I do that, it's going to be a standard result, but if I add a space there, the first character of that string is going to change. Now, at this moment of time, Anirudh Rao is going to remain the same thing as well, right? Now, that is a little tricky question for you guys. Now, I want you to head to the comment section and tell me why that happened, right? Fantastic. Let's move on to question number 27, where the question states, how can you insert an element at a given index in Python? Well, it's a very simple question. It's a straightforward question, yet it seems like it's such a complex one. But of course, when you're in the interview, when you ask a question such as this, it is very easy to get confused, right? That is the entire point of this. Now, how can we go on to add an element at any given index? Well, it's as simple as using another function. This time, the name of the function to do this job is called as the insert function, right? It can be used to insert any element that you want at any particular index location of your choice. Now, to just state this out might not give you complete clarity. So, of course, we're going to take a look at this practically as well. Look at this. Can you insert an element at the given index, right? Now, this is the list 0, 1, 2, 3 all the way up to 7. Now what I want to do is I'm going to use the insert function. Now if I just say insert 10, the question that's going to be asked is insert 10 where? Right now I have to give the index position at which I have to insert a value. Now all that this is stating is insert the value at the 6th index. The question is, okay, what is the value? Well, the value is 10, right? 6th index, put the value 10 there, and as soon as we go on to print it, you will see that it's pretty simple, right? Now look at this particular gap. Here we have 5, 6, and here we have 5, 10, 6. So 10 was inserted at the 6th index position, right? 0, 1, 2, 3, 4, 5, 6. Python came here and it was like, okay, I have to add it here, but there's already 6. So 6 moves to the right and it gets wedged in between 5 and 6. That's the reason we have 5, 10 and 6. Now what if I want to have it as 15, right? Now let me just change the comment as well so that you guys don't get confused. As soon as I run this, well, the value 15 gets added to the 6th index location. Pretty simple, right? Superb. Coming on to question number 28. Question number 28 states, how do we remove duplicate elements from a list? Do we have a function? Do we have a method? In fact, there's multiple different ways of how you can remove duplicate elements, right? The easiest way, in my opinion, is to take a list and convert it into a set by, of course, using the set function and eventually using the list function to convert it back to a list if it's required, right? Now, you might be wondering, hey, we're trying to remove duplicate elements. Why do we have to convert it to a set? How does a set work? A set literally states it is a collection of unique elements. There is no repeated elements in a set. So if you have any repeat elements that you need to get rid of, convert it to a set. Set will automatically throw out all the extra values for you and you can convert it back to a list and eventually you are done. How simple is this? Let me show it to you. Again, it's 2 or 3 lines of code, right? Okay, first of all, I'm going to be deleting the list here because we've been using lists of the concept multiple times. So you can ignore this line as of now. Your heart of the logic, the one line you should be concerned about is this one. First of all, we have a list. The next thing is we're taking a list and converting it into a dictionary or a set or anything that works. And in this particular case, you can also use from keys. From keys also works fantastically well. As soon as I run this, now what are the duplicate element that we have here? X, Y, Z, Z and S. So Z is the repeated guy we need to get rid of. And as you can see, once we run dictionary.fromKeys, or eventually you can use multiple ways to do this, as I told you. Now I want you guys to head to the comment section and tell me another way. I told you one way to do it and I showed you using another way as well, right? Now how do you convert it to a set and convert it back? Guys, head to the comment section and give me the logic for this. Right? Superb. Now let's get back to our deck where we're going to discuss question number 29. Question number 29 is a very important one because here we're talking about a concept called as recursion, and recursion seems to be the most famous concept, the most asked concept in an interview, right? Be it data structures or Python. So what is recursion? Well, recursion is nothing but a function calling itself to have multiple functionalities over the same piece of code. If you have a function that calls itself, you can actually pass any different value that you want and get the function to have its behavior, but use different attributes to give you different results, right? But one thing you have to mention if the talk is about recursion is please don't fail to mention that you really have to terminate a recursion statement by either giving a condition or manually terminating it. Now, if you do not terminate a recursion, it's like the function calling itself. It just keeps going back and forth. And how long is it going to go for? It's going to go on for infinite times. It's going to create an infinite loop if you're not very careful about this. So if you're asked about recursion, make sure you're specifically mentioning about its usage and its termination as well, because it's very easy to use recursions and it is very easy to miss the termination and send your entire program into an infinite loop, right? Fantastic. Coming on to question number 30. Question number 30 states, explain Python list comprehension. What is list comprehension in Python, right? We know lists, but what is comprehension that we're talking about? Well, list comprehension basically talks about the operations of how we can convert one list into another. Basically, instead of convert, the better word to be used here is transform, right? Elements that are basically that you can conditionally transform are present in the new list, and each of these statements that you want to pick, right? There are 10 statements. You want 8 to be transferred into another list, or you want this to be transformed and create another list just from a substring, just from an element that is present here. Is it possible? Will be the first question, the answer to which is yes. The second question is how, and here is how. Right? Look at this. We have a list here, but instead of me manually specifying 1 to 1000 elements, 1, 2, 3, 4, all the way to 1000, I just ran a for loop there, and as soon as I hit print, it's basically going to actually print 1000 elements, 0 to 999, right? I'm scrolling left to right. Look at this. It did all of that, but this is comprehension. We're transforming a list. Right now, if I had to do this manually, again 1, 2 all the way to 1000 would be the way to go, but we are intelligent programmers and we made sure we understand comprehension as well, right? Fantastic, guys. Now let's move on to question number 31. What is the use of the bytes function in Python? Now, what would be the use of bytes function in Python, right? Well, it's very straightforward, ladies and gentlemen. The bytes function in Python just returns a simple byte object, right? If you have any object that needs to be converted into a byte object, or let's just say you want to create an empty byte object of the specified size that you want, you would just go on to use this function, right? It's extremely straightforward. It is simple. So when you ask this question, make sure your answer is straight as an arrow here, right? This is a very important question, right? Coming to question number 32. Question number 32 states, what are the different types of operators in Python? Now, this question can be asked earlier as well, and especially if you guys are freshers just out of college looking out for your first Python job, this is a question that will be asked. So ladies and gentlemen, whenever you ask this particular question, just make sure that you're talking about the arithmetic operators, which is basically addition, subtraction, multiplication, division, and the modulus operation, the percentage symbol there, right? The modulus operation returns the remainder, right? Now that's a very important thing, and it's a very different output compared to a regular division as well. Don't forget that. And of course, you have the relational operators, right? Less than, greater than, less than, equal to, greater than, equal to, of course, equal to, and of course, not equal to, right? Now I said equal to, but you just say it as equal to once. Next, we have the assignment operator. Assignment operator is equal to, plus equal to, minus equal to, right? You might have seen something such as a equal to a plus 2. Instead of that, it'll just say a plus equal to 2. A plus equal to 2 literally is the same as a equal to a plus 2. We just shortened it down to an even further degree, right? Now, of course, this is done in multiple programming languages, but since Python also offers support for this, I love it, right? Fantastic. Next, take a look at the logical operator. Ladies and gentlemen, there are 3 logical operators, and or not, and basically it will give you a true value if both the values are true, else it's false, or it's a different game. If one of the 2 values is true, any of the 2 values is true, you will have a true output. Not is a fantastic way of approaching a logical solution. If you provide a true, it's going to reverse it and give you a false. If you provide false, it's going to reverse and give you a true, right? But of course, there are other types of operators you guys have to talk about as well. We have identity operators. We have bitwise operators. Now, there's bitwise operations, as in bitwise bitwise and bitwise OR, right? There's a difference between bitwise and logical operations, and I want you guys to tell me what it is, right? Fantastic, guys. So if you ask the different types of operators, make sure you're talking about these. Right? Okay, now to come to question number 33. Question number 33 states, what is with statement used for in Python? The with statement, right? What is it used for? Well, with statements is super popular for one very important application in Python, which is exception handling. Ladies and gentlemen, you will come across exceptions even though you want it or not. So to handle these exceptions, we have multiple methodologies in Python, and the with statement is at the heart of that as well, right? Now a file can be opened and closed whenever you're trying to execute a code block which has the with statement in it, right? If you open a file, you have to close the file as well. But if you're opening it with respect to exception handling mode and we're trying to use the keyword with there, you really can get away with it without using the close function for the file as well, right? Now look, I used a conceptual example to denote the logic, the working, the application, and to talk about where it is used and the level of difficulty as well. We are making it way more easier to read, reducing the code, and eventually we know it works well in exception handling as well. So this is an important point that you really have to think about, right? Fantastic. Coming on to question number 34. Question number 34 states, what is a map function in Python? Map function. Have we ever used a map function? Well, the map function basically is used for applying functions to an element which has a specific iterable in its case. Now, you might be a person here right now saying, hey, what are you talking about? I've never used the map function. I don't know what elements you put in. I don't know the syntax. I don't know what an iterable is, right? Well, let me tell you this. Map function is a very simple function that you try to apply, function on not just one element, but all the elements. Now, there are certain parameters you have to pass to this. There are two parameters. One is the function itself, and of course the iterable that talks to the function, right? Let's quickly take a look at this practically so you have better understanding of what it is that I am saying right now, right? Look at this. First of all, you can ignore this line again. We're trying to delete the list there. We have a function here. Now, what the function is doing is basically try to, no matter what input you give, a numerical input is going to multiply it by 3 and give it back to us, right? Look at this. We have 1, 2, 3, 4, 5, 6 here. Result equal to map. Look at this map function, and I said function comma iterable. This is the function that I want applied on every single element of the iterable. Get it? Now the logic, what's going to happen is in the first place we're going to get 1 into 3, second place 2 into 3, third place 3 into 3, 4 into 3, 5 into 3, 6 into 3, and at the end we're just converting it back to a list and printing the result of it, which just states this, right? We gave 1, 2, 3, 4, 5, 6, but we got 3, 6, 9, 12, 15 and 18. What's the logic? The logic is here. We multiplied it with 3. But did we just do it for one element? No, we're trying to apply a function across all elements over an iterable. What is the iterable? It's tuple. Well, what are we doing here? We have 6 elements. Multiply each with 3 and you're good to go. Right? Fantastic, guys. Now, let's take a look at the next question, which is question number 35. Question number 35 is another extremely popular candidate which says, what is the init method in Python? Now, the init method is basically a reserved method in Python. You cannot use this for anything else, just like the reserved keywords that we talked about, right? Now, since Python is an object-oriented programming language, it's an OOP language, this here, in the case of an OOP language, this method, init method, is basically nothing but a constructor, right? When you create an object, the object belongs to a particular class. The init methodology basically is used, and it is eventually called to actually access the class attributes that we have for that particular class wherein we're talking about the object, right? So init is nothing but a constructor. In the constructor, this methodology is used to call the access of the particular class attributes, right? It's a simple, straightforward answer, but don't just say that it's a reserved method, or don't just say that it's a constructor. Have one more, go one more step ahead and give out the third point as well, right? That's a very important point. Fantastic. Now let's take a look at question number 36. Question number 36 states, what are the tools present to perform static analysis? So static analysis is basically how we can go on to find bugs in Python, ladies and gentlemen. Now the tools that are present in Python to actually go on to do this, we have two tools. One is the PyChecker and the other one is the PyLint, right? Now I am sure you guys might have used one of these things to detect maybe bugs in your source code, or even to warn about the usage of variables, the style, the complexity, and all of that as well. Now that, whatever I just mentioned, is the forte of PyChecker. But what is PyLint doing? PyLint will basically check if your particular module matches up to a set coding standard or not. Now there's multiple coding standards that one has to adhere to when working with this. PyLint is a fantastic tool that will help you answer the question saying, hey, is this coding standard being met or not? If you have a question such as that, PyLint is the basic tool that you will be using to give an answer to it, right? It'll either be a yes or a no, and if it's a no, it's going to tell you why it's different as well. Right? Fantastic. Now coming on to question number 37. Question number 37 is an interesting one because it states, what is the difference between a tuple and a dictionary? Well, tuple and a dictionary, right? Now the major difference between a tuple and a dictionary that you just have to say it as the first point is that tuple is immutable while a dictionary is mutable, as in you can add values to the same dictionary as you choose for any number of values that you want to add. It is possible, but in the case of tuple you cannot. Once it's created, those values are fixed for that tuple. If you want to add new values to a new tuple, you create a new tuple there, right? The content in the dictionary can be changed. The content in the tuple cannot be changed unless the identity of it is changed, right? Now look how I nicely put out the answer that eventually gets across the point as well, and eventually gives you details about its identity, about the values, about its mutability, and of course to talk about what a tuple can do and what a dictionary can do that a tuple can't do, right? Super. Coming on to question number 38. Question number 38 states, what is parse in Python? What is parse? Is it a function? Is it a module? What are we talking about? Well, it's not any of these, because parse is basically a statement which will eventually do nothing when passed. You remember how when you're playing games, you say, hey, I pass. It's literally that in Python. Now you would say, why is that required? Well, it is a null statement, right? Now you cannot say we don't have use for null, zeros. Zeros in fact are entities on their own. None is something which is super important. Null, N-U-L-L, null is also super important, right? So you might think saying, hey, will it just be skipped by the interpreter like how the Python interpreter skips all the comments? No, this is not skipped by the interpreter, but whatever you try to pass will eventually not be executed. It's like the turn of that particular statement is passed on, right? Like you move on without executing that particular one. That is parse. Now it is used when you actually do not want to have any sort of commands to execute, but you don't have commands to execute, rather you have a statement that is required there, right? Now if this is the exact case, talk about what it does, talk about why it's doing that, talk about how it's being done, and give one more example to state another condition which you might also face, right? Look at the 4 points. It is exactly aligned towards what I just said, right? This is how you should also formulate your answers when you're giving it out to the interviewer, guys. Okay, fantastic. Coming on to question number 39. Question number 39 states, how can an object be copied in Python? Now, even though you look at the even though you don't look at the answer, you just saying, hey, we have an operator that does exactly that, right? We have the equal to operator that can go on to copy any sort of object you want to again, any sort of variable that you want. Look at the example that's on your screen, var equal to copy.copy of object. All we are trying to do here is we're trying to copy an object to a variable, but now I just said that you can copy any object that you want to any variable that you want. There is a certain catchphrase here. Not all objects can actually be converted in Python. Of course, 99% of them can be done. Now there are certain objects that cannot be copied in Python. Right now, while you're watching this video, take a second to pause it. Find out which is the object that cannot be copied in Python. Head to the comment section and let me know. I'll be more than happy to take a look at your comments, right? Fantastic. Coming on to question number 40. It states, how can a number be converted to a string? Well, we already saw numbers in the form of a string, but literally there is another inbuilt function called str as in string that is used to convert what? A number into a string, right? Again, as always, we have to check this out practically to understand this. Now let me quickly scroll down here. Yes, you can see n equal to 10. We have a number, right? Number is 10. As soon as we print n, this is still going to say it's a number, it's an integer. But look at this. The next time we're using it, we're calling a string function and passing the value to it. So the type of the new string that's generated, what is it going to be? Let's take a look at it, right? First one, this type, this number says it's an integer. It's a number, correct? Next one, as soon as we run it, after this logic has run, it says that it is a string, right? Now this 10 is not numerical anymore, but it is considered as a string. If you have to start out with a string, all you do is this. But my logic says do this, right? Now that's an important thing you guys have to know about, right? Fantastic, guys. Now let's just move on to the next question, which is question number 41. Question number 41 states, what are modules and packages in Python? Modules and packages. We've been using a lot of modules and packages as of now, right? NumPy, pandas, and all of that. Now that is one side of the thing. Now the other side of the thing you have to understand is that with respect to modules, why are modules used and what are they? Modules basically try to split your program and give it some meaning on its own. It tries to add structure to an existing program, right? You might have multiple Python programs which is basically used for one different application or one single application. I'm sorry. Now when that is the particular case, you're gonna have to import other attributes, you're gonna have to import other objects, and you're gonna have to import multiple files to get the functionality of all these objects, right? That is exactly why this is used for as well. Now if there is a folder where a program is present, it is nothing but a package that is consisting of multiple modules. I think now you would have definitely got the full picture of what modules are, right? But one important thing you really have to think about is that a package can only have modules or subfolders, right? You cannot have anything else apart from modules or subfolders in a package. Of course, you might be saying, can we have programs? Of course, we are having programs in the case of modules. In fact, many programs are possible. But apart from this, is there anything that's possible? The answer is no. So ladies and gentlemen, when you ask this question, talk about what it is, where it is used, how it is done, and what is it that you should not do as well. For example, if you're talking about tuple, say that it's immutable, right? Because that is its characteristics. Whenever you're talking about modules and packages, this is the characteristic you have to talk about, right? Fantastic. Now let's move on to question number 42. Question number 42 states, what is the difference between NumPy and SciPy? Well, what an interesting question, right? Because NumPy stands for numerical Python, while SciPy stands for scientific Python. NumPy is a fantastic library which is used to perform complex numerical operation on the lines of defining arrays, solving mathematical problems, and a lot more. We saw a lot of NumPy with these questions already, right? Of course, going ahead, we're going to check out more as well. But then when you're talking about SciPy, SciPy stands for more scientific applications on the lines of statistics, on the lines of applied mathematics. Think about things like integration, think about differentiation, think about all the data points that are required in terms of statistics for machine learning as well, right? When that is the case, SciPy is super popular for that. Of course, even for machine learning, you're going to require NumPy to handle data for you, but it's not that without NumPy you cannot do it, right? There are manual ways of how you can do it as well. It's not NumPy that's providing functionality for machine learning, but once you figure out how these algorithms work, you're going to understand the importance of SciPy as well, right? So you can actually brief the interviewer regarding the answer in this way too. Right? Fantastic. Now let's take a look at question number 43. Question number 43 is a rather straightforward one. It states, what does the len function do? L-E-N, len. Now the len function is short name for length, L-E-N-G-T-H, right? Length. So what can you find the length of? Well, you can find the length of a string, an array, a list, anything that you can count, you can find the length of it, right? So let's actually take a look at it practically. Now this is again a very simple example here, right? We have a string here. The string is called Great Learning. Of course, welcome to Great Learning. Do take a second to subscribe if you're loving this video, right? Fantastic. Now what are we trying to do next? We're trying to, instead of just printing out the string, which is again no point, we're trying to print the length of the string here. Now as soon as I hit play here, it's going to basically say 14. But Great Learning is not 14 characters, right? Great Learning. Well, it's 13. Where did 14 come from? You see this beautiful white space that is sitting in the middle. Let me select this space. That is also considered with length. But now if I hit backspace and if I make it one word, the answer is now going to be 13 instead of 14, right? So when you're talking about the length function, give an example, specifically say, hey, I know that if you use a white space, that is also counted as well. That way of approaching and attacking the problem is impressive, right? Again, very simple, straightforward question, straightforward answer, right? Let's go to question number 44. Question number 44 is diving right into the heart of object-oriented programming. It states, define encapsulation in Python. Encapsulation is capsulating something, putting something into a capsule, locking it away. Now, right, why do we want encapsulation? Encapsulation ensures that you're actually bringing a tiny piece of code together. You're bringing the code and the data together in a way where access to that particular variable there, the scope and the lifetime of the variable is basically meant for that particular class, right? Again, encapsulation is a very important part of OOPS as well. In fact, you use encapsulation in your real life. Just open your wardrobe or your cupboard, right? If you open your wardrobe or your cupboard, your clothes are all on the inside and you close it and you lock it away, right? It's not like you display every single one in your room every day. No, I don't do that, and I'm sure you guys don't do that as well. Now, when that is the case, you're actually encapsulating all your clothes. When you want it, you're going to use it, but when you don't want it, it is stored away. And you can also lock the cupboard in a way where you can have access. You can have access, but someone else can't. You can do that in Python as well. And a fantastic example to go on to do this is nothing but a Python class, because a class makes sure that there are objects inside it. And once you have a class and objects associated with that class, there is the concept of lifetime and scope, which will eventually protect the entire class, right? That is encapsulation. Now let's take a look at the next question, which states, what is the use of the type function in Python? Type function. Don't you think we already use this multiple times now, ladies and gentlemen? Well, type function is nothing but a built-in function that will give you the type of an object that we are trying to work with, right? It'll also, here's the catch. Look at second point, guys. It says it also returns a new type object based on the arguments passed. Of course, whenever you're passing your arguments, you might be changing the functionality of what's going on there. So you might be passing an integer, you might be passing a floating value, you might be passing a character string. We already took a look at this at question number 40, right? So if you just skip through the questions, make sure you head back to 40 to understand the functionality of type as well. Right? Fantastic. With this, we'll take a look at question number 46. Question number 46 states, what is the split function used for? Split function. Well, what does the name suggest? Split, as in take something, split it, right? It is literally that, guys. We're going to be splitting a string into shorter strings by making use of this particular function. It can be done in a random way. It can be done in a very structured way, as in you can tell where to split what in terms of which data structure as well, right? So the amount of breaking that you can do to bring something to its most simple level is magic, right? Let's take a look at this practically now. This is the question that we were discussing, right? What a split function. Look, we have letters equal to A, B, C. Now, this is one entity. This is one element, right? It's not like I have double quotes for all each of these entities. Now, what I want to do is I want to split, and I'm going to split it by having a comma there. As soon as I run the dot split function, look at this. These are three individual elements instead of just ABC being one individual element. And I'm splitting it by, right? Now, ask a question when you don't understand the syntax. If you want to split something, the next question is going to be, okay, split it where, or split it using what? The what is basically this particular comma that we're using, right? We use that to say, hey, after you find every comma, create a separate object and split it for us. Right? Fantastic, guys. That is 46. Let's move to 47, which states, what is docstring in Python? Ladies and gentlemen, what is docstring, right? Now, a docstring is something which is super important for Python programming language to work, because when you're talking about all the string literals, right? Whenever you put anything in triple quotes that appear, whenever you're using a function, there's triple quotes and there is something related to either the definition of the function, the method. It can also appear in a class. Of course, you can also use it for your module as well, right? So it's literally string literals. let me rephrase that. It is string literals that is enclosed in triple quotes that you would find appear to the right of the definition of be it a function, be it a method, class, or even a module, right? Generally, when we try to describe the functionality of any particular function, method, class, or module, we try to use the docstring. The docstring literally answers the question saying, okay, so how? If you're defining something, how does it work, right? So to understand the functionality, the docstring is very much important. Now, the interviewer might ask a question saying, okay, so where am I going to find this docstring? You already said that it is found right to the right side of the definition of a function, but all of these docstrings are present in one particular attribute, which is the underscore doc. Again, another underscore. Like it's very similar to init. The syntax is very similar to init, underscore init underscore, but instead of that we have double underscore doc, double underscore to end it as well. This is question number 47. Well, coming on to question number 48, the most popular function to ever exist, to be asked for interviews, which is again the lambda function. So what is the lambda function? How does one go on to use it? A lambda function is us trying to create a simple temporary function, which again does not have any names, no definition, no return type specifier, which is us having to specifically mention all of these. It's all an intricate dance that happens in the back end. At the front end, all I want is to use one logic and I want a function that does it really quick. If that exactly is the requirement, all I would use is a lambda function, right? Mostly lambda functions are never used as standalone functions. They'll be used as an argument to another function, to another higher ordered function. So you're talking about what lambda function is. Make sure you're also talking about where lambda functions are used, right? Now, as always, to give you more clarity, I want you guys to take a look at this practically, guys. Now look at this. I have a function here called triple. Now triple says lambda x such that. Now this particular colon that you see here is read as such that, right? It's I would read this as a lambda function such that x multiplied with 3. So any value that I pass as an argument, I'll get the output of it being multiplied by 3. If I send 5, what is 5 into 3? 15. What if I send 100? 100 multiplied by 3 is 300. So that literally is the answer that I'm going to get, right? Pretty simple. This is a pure working function that would just give you the entire functionality instead of me typing def triple return x such that return x into 3 and eventually call the function, pass the value, print it out. Instead of using 7 lines, we just broke it down into 1 line, right? It's literally that, a short temporary function which we would want to use. Right? Superb. Now coming on to a question which is super popular. It says, how do you find the factorial of a number? You have multiple math functions of how you can do it, right? It's literally passing a value as an attribute, you have the answer. Python will give everything to you in the shortest way possible. But read the entire question. It says, how do you do it using recursion? Right? Now you have to manually implement the logic. As we have already discussed, recursion is a situation where the function calls itself. It can be same attributes or different attributes. But one important thing is that we have to set a stop condition so that it doesn't go on doing the same thing again and again and cause what? An infinite loop. Fantastic, guys. Let's take a look at question number 49 here, right? Now, I have a very simple function here called as factorial. I've defined a function. I have one attribute. Now, what is 1 factorial, ladies and gentlemen? It's 1, right? If it is anything apart from 1, we eventually are going to have to work on the factorial, right? Now, what is 2 factorial? It's not just 2, it's 2 multiplied with 1. What is 3 factorial? It's 3 into 2 into 1. What's 4 factorial? 4 into 3 into 2 into 1. What is x factorial? X into x minus 1, x minus 2, so on, so on, so on. We've read it in school, right? We have to forcefully specify it for 1 because there is no logic. If you do not specify this as 1 factorial will be 0. Is 1 factorial 0? I don't think so, right? Now, what do we want? Let's have 5 factorial, right? 5 factorial is a fantastic number. So as soon as I go on to run this logic, it's going to say 5 factorial is 120. Now, how did I get 120? 5 into 4 into 3 into 2 into 1. But hey, where is all that going on? Where is the recursion going on? Look at this. We are returning a value and eventually multiplying the returned value by calling a function and reducing that. So with this, if it is 5, it will basically say 5 into what? 5 into a minus 1 is 4. And eventually it's going to run again. 5 into 4. Okay, it's going to say 5 into 4 into 3. It's It's going to run again. 5 into 4 into 3 into 2. Now it becomes 1. It's like, oh, okay, if it is 1, it doesn't run this logic. If it is 1, it will just state 1. Right? 5 into 4 into 3 into 2 is executed all the way here, but that last one is defined here and executed, right? You can have the factorial of anything, right? Let's have a really big number. What is the factorial of 200? Now, there's going to be a huge number, right? Look at this. This is the factorial of 200. Look at the size of this number, ladies and gentlemen. Let's have something simple. 3 factorial, right? The answer is 6. Let's take a look at that. There we go. The factorial of 3 is 6. Fantastic, right? That's the 49th question. Now let's take a look at the 50th question, which says, how do you denote the working of the bool function with examples? My suggestion, ladies and gentlemen, whenever you're walking into a Python interview, please carry your laptops, have your Jupyter Notebook up and running so that when you're asked questions such as this, you can just open up your laptop and start typing in your code, right? Because the working of the bool function is very simple yet very confusing for a beginner, right? Of course, we already know that the bool function can only give yes or no, 0 or 1, true or false. But for what conditions does this behave as true? For what conditions does this behave as false? That is exactly what we are going to check out in question number 50 here, right? Take a look at this. Here, basically, I have a equal to hello. This is a simple string. B equal to 15. This is a non-zero integer number, and C equal to 0. And I have a sample list, but I have not given any values in the list, right? This is an empty list. Now, as soon as I run this, I'm supposed to get true, true, false, false, right? Boolean of A. Why is that the case? Well, Boolean functions functionality is fantastic. It will provide the output true as default unless it sees none, unless it sees null, unless it sees 0, and unless it sees empty elements such as empty list, empty set, empty dictionary or something like that, right? When it's empty, none, 0 or null, you're going to get false. Everything else apart from that, you're going to get true. That is the most simplest way. You can just use one 2-liner example to showcase, quickly type it out and hit enter in the interview, and you can just show it. And of course, now that all the interviews are going on in a virtual way, you'll be on a Zoom call or you'll be on a Google Meet or whatever it is. Just quickly start sharing your screen, open up a notebook, ask if you can type the code and show it practically. I don't think no interviewer would say no to that, right? So you have to do it quickly though. You cannot take your time to do this. But then now that you know how to go about working with the bool function, I am confident that you guys will answer this, right? Fantastic. Now coming to a section where we'll actually be taking a look at some really important interview questions, but for experienced users, right? Now there's variable levels of expertise, wherein when you're applying for a job, you might be a fresher, you might still be in college looking out for applications, or you're a person who has 1 or 2 years of experience in the domain itself, but you're still looking forward to understanding what are some of these advanced questions, right? These questions which are not as simplistic as the ones that would have been asked if you were a fresher, right? Now we're going to cover all of those in that, and of course after this, in the next part of this video as well, right, we're going to be taking a look at some really important tricky questions, guys. So make sure you're paying attention. Right? Fantastic. Now to come to the first question, it states how to create a new column in pandas by using values from other columns, right? So we already have a data frame in pandas, and what we want to try to do is we want to create a new column, but we want to already use existing values from another column, right? Now, of course, we've already seen how we can work with a data frame in the beginner's question. So if you do not know how to work with data frames, guys, I highly suggest you just step back and take a look at the previous questions and eventually move forward to here, right? With that, to answer the question, of course, the pandas columns, all these numerical values that are there, we can operate on it based on any requirement that we have, right? There are operators, data frame supports the operation, and eventually we can go with not a lot of code, right? Let's take a look at this practically to ensure that you guys have complete understanding, right? Now, let me quickly zoom in so that all of you all can see. Right? Superb. Here is the first question now. How to create a new column in pandas by using values from the other columns, right? First of all, we're going to be importing the pandas library. Next, we have, 2 lists out here. We have a dictionary definition, column 1 of A, column 2 is the value for B. We're creating a data frame out of it. And once we create the data frame out of it, this is where the logic is happening, guys. So what we're trying to do is we're trying to sum up both the columns into a data frame, and eventually, you can also do the difference operation operation as well. As you can see, we have sum operation, we have difference operation, and all we're trying to do is a direct plus or a minus operation there, right? Now let me actually hit run on this piece of code. You will see this, right? Column 1, column 2. Now what is the sum of column 1 and 2? You can see it in the sum tab. If you want the difference of column 1 minus column 2, eventually it'll be there, right? Now if you're thinking about, hey, this is a negative number, why am I seeing negative numbers? That's because the data in column 1 is less than the data that's present in column 2. You can definitely change this. If you just want a new difference, all you have to do is column 2 minus column 1. Now this would again depend on the application that's been asked. So if you're usually asked to actually pick up columns and just use values from other columns as well, you can do that, right? Now C1 plus C2, this is the sum. C2 minus C1 is the difference that here, right? So I hope we are clear with question number 1. Fantastic. Let's move on to question number 2. In question number 2, they're asking what are the different functions that can be used by group by in pandas, right? Now again, if you haven't taken a look at group by, we've actually used this previously as well, so make sure to take a look at that. Now, one thing all of you all should understand is that group by is a fantastic function that's provided in pandas, wherein we can go on to work with multiple aggregation functions, right? Now, when I say aggregation, you might have definitely used all of these in Excel. Think about the average function, the sum function, think about min, think about max, think about mean, sum, count, standard deviation. All of these are called aggregate functions or aggregation functions, right? So what we usually do here is that with all of these functions, they have their own purpose. The sum function will eventually add up all the values. The mean function will eventually just give you the mean of the data that you have passed through this. Now again, if you have already noticed that from the previous section, we have used the sum function, we have used the mean function, we have also used the standard deviation function, right? So we have used it previously, right? So if you haven't had a chance to take a look at it, again guys, I highly suggest you do. Right? Fantastic. With that, let's take a look at question number 3. Question number 3 seems to be a really big question, but trust me, it's a fantastic, it's a very easy question to answer, right? So it says how to select columns in pandas and add them to a new data frame. And that's not the end of the question. Of course, if it is asked in a manner saying, can you add new columns into a new data frame? Of course, the answer is yes. So once you say yes to that, they'll ask you how. Once you answer how, there's a very good chance that the interviewer might also say, okay, so what if I have 2 columns with the exact same name? What do you do then? Right now, we're covering 3 big answers in one of this particular question itself, right? Of course, if df is basically data frames in pandas, df.columns will give you what? A list of all the columns. We've already seen this, right? So if we want to go on to create new columns, well, what do you want? What's the new column that you want? You'll have to select it, right? Now, when you go on to create these new columns, all you have to do is select it if they have both the names. I mean, if both these columns have the same names, then eventually they get copied on to the new data frame, right? So the question asks, how do you select it and add them into a new data frame? And what if they are common? If they're common, it's well and good. Directly add them in and they will the data will get added on to the new data frame. Pretty simple, right? But then when you take a look at the question, it definitely is overwhelming, and this is a very common question that is asked for experienced users as well. Okay, coming to question number 4. Question number 4 asks how to delete a column or group of columns in pandas. Given the below data frame, please drop column 1. Right now, let's take a look at the data frame here. It's a very, very simple data frame. There's 2 columns, column 1 and column 2. Now, what they want to ask you to do is basically drop every single value that's present in column number 1. They might also phrase another question like drop, instead of just saying drop the entire column, they might say drop the data that is present in the column as well. And of course, guys, we already know this. If we have to work with columns, if we have to delete anything, the drop function in pandas is absolutely beautiful for working with data frames, right? So you can see the input. What you see here that I'm moving with my mouse, this is the input. What we want is column 1 removed. So as soon as column 1 is removed, this will be our final output data frame, right? So let's take a look at this and understand it practically. So this is the question we were discussing, question number 4. How do you delete a column or a group of columns, right? Now, we have the columns that we have put out here. We have column 1 with data 1, 2, 3, column 2 with data A, B, C. Now, as you can see, we are creating a data frame of the data that we have, and this is where all the magic happens, right? df.drop of column 1 will eventually remove everything that's present there. Now, as soon as I run this, you will see that even though we input 1, 2, 3 for column 1, that is pretty much absent, right? right? That is the magic. In fact, question number 5 is sort of an add-on to this particular question. It says, hey, given the data frame, why why don't you remove everywhere, remove all the rows where the column value is A, right? Now let's take a look at this. Which row has A? Well, it's column 2 but row 0, right? So we want to remove everything with row 0 and column 2, which is basically A. Now how do we go about doing this? The drop function will drop the column, but the drop NA function is used to drop these individual values that we can work with, right? You can take a look at the input and the output here. In the input, you can see that it says 0, 1, A, but in the output, this entire row is completely deleted and it starts from this row, right? That is all that we're trying to achieve. Wherever there is A, just cut it out, right? It's pretty simple. Now, let's take a look at the code. As you can see, pretty much all of these lines are as simple as this, right? As soon as I go on to hit play here, we will have the input data frame. Now, this is what we have, but the logic comes into picture here, ladies and gentlemen. I made it into a comment so that we can take a look at the original one before actually having to take a look at the modified output, right? Look at this. Instead of using just drop, we're using drop NA, and of course, right, wherever column 1 is not equal to 1, we are trying to drop those columns. Now, as soon as I hit enter here, you can see that this is the input, this is the output. You see that 01A has vanished from the output, and all it took pretty much was just one simple line of code. Simple, right? But at the same time, when you're in an interview, all of these can be pretty tricky to actually think about and provide a solution. Anyway, let's take a look at the 6th question. Now, this again is a huge question, right? Given the below data set, find the highest paid player in each college in each team. Now, what are they asking for? They want the highest paid player. So where are we talking about money? There we go. We're talking about the salary, right? Now, once you understand the salary, they just want to find out who's the highest paid player, right? And you have to split it out college-wise. Now, you might be thinking, taking a look at this data set, saying, hey, Anirudh, this is going to be a very long problem. We're going to have multiple Python steps to do this, right? Well, the answer is absolutely no. It can be done in one very simple line by making use of the group by function. As you can see here, what do we want first of all? We want the maximum salary of these players. So what are we trying to do here, right? Take a look at this. We're trying to find, we're running an aggregation function on the column salary, but we're trying to group them by the team and the college, right? Again, as I told you, it's one simple piece of, one simple line of code that can do a lot and eventually answer a very long question with a tiny answer, right? The code, in fact, is smaller than the question itself. That is the magic of Python, right? Superb. Coming to the 7th question. The 7th question states, what is reindexing in pandas? We know that every single data frame or series that we use in pandas have indices, right? That is the location that we use to actually work with the objects that are present there, the entities that are present in a list, in a data frame, whatever it is. Now, when we're trying to reindex, all we're trying to do is we're trying to reassign the index, right? Reindex is basically a short form of reassigning the entire index. That's about it, guys. To actually add on to more, instead of you just saying, hey, reindexing is just realigning the index, I want to make sure you guys give a comprehensive answer. Let's quickly take a look at one simple example, right? Let me zoom out a little. Fantastic. What is reindexing? Okay, so what are we doing, ladies and gentlemen? We're importing pandas, the library, of course. We have a couple of bikes in a list. We have a couple of cars in a list. And all we're trying to create is a two-dimensional data frame with that. But if you take a look at this, these 3 lines is where all the magic happens, right? First of all, we are trying to create the data frame. Without the data frame, you cannot do anything. And once you have the data frame, we need new indices value, right? New index values that we need to put. So we'll have to create a list and use this list. The data that is present in this list will become the new index, right? How do we do that? df.index. We have the .index helper that will eventually get us to do this. And all we have to do is assign it to the values that are present here. Now let me quickly go on to run this piece of code. Instead of this saying 0, 1, 2, 3 and 4, it's saying 10, 20, 30, 40 and 50. That's because I have told it, hey, I want my own index values, not what you provide. So please use this, attach it as an index. How cool is this, guys? There's not a lot of code that you can actually have, but then the output is pretty impressive all the time, right? Fantastic. Now coming to one very important concept, as we already discussed in the beginners section, the lambda function is usually asked a lot because people tend to stumble upon either writing the logic or not answering it fine, right? So let's take a look at question number 8. Question number 8 says, create a lambda function which will print the sum of all the elements that are present in this list. Guys, take a look at it on your screen. There is a list given. There are a couple of elements, right? There's somewhere around 6 elements in this list. Now, we already know how lambda function works. It's basically a temporary function that we use. It's a nameless function that we can work with, right? Now, all we have to do is take in any and all the elements that are present in a particular list, add it up, give out the sum, right? Again, this is a very simple example, but it can get really confusing. So let me break it down into simple terms, right? Now, this is a short program. I can zoom in a little. First of all, we are trying to use this logic, guys. Basically, we have one fantastic library called as function tools, or it's also called as func tools. From there, we are trying to use this. We're trying to bring in the reduce methodology, and all we're trying to do, right? The lambda function logic, it lies here. For every single element, lambda x of y such that x plus y. All we're trying to say is, hey, all the elements that you see here, just add them one by one in the order, and eventually just store it all in a variable called sum and print us the sum value, right? So you can see that there are sequences 5, 8, 10, 20, 50, right? Now, as soon as I hit run, all it is trying to do is add all of these elements. 100 plus 50 is 150, 170, 180, 188, 193, right? Now you can have any number of elements that you want, guys. So maybe let's just say I want another 100, right? Now the output I should have is 293 instead of 193. Let me just go back on this so that you guys will make sense of the question as well as the answer, right? 193. Absolutely fantastic, guys. Now we're going to be discussing another pretty important question. It's called as the VStack. Now VStack, HStack basically stands for vertical stacking and horizontal stacking. These are really important questions that have really high probability of being asked, right? So please pay attention here. The question states, what is VStack in NumPy? Can you please give an example for the same, right? Now NumPy is super popular for as a library itself. Now its popularity comes from functions such as VStack, right? Whenever we have all this data that's present, where we have to align it we have to align all these rows vertically, that is when we're going to be using VStack. Literally the answer to the question lies in the name itself. VStacking talks about you guys vertically stacking these values. But then, hey, it's very important to note that all these rows that you're trying to stack, they must have the same number of elements to make sure that nothing gets skewed, right? As always, even though it's a theoretical question that they have asked you, the interviewer might have asked you, do take a second to maybe either write down one line of logic. Basically all you have to write is this line of logic, right? Now look at this. We have a one NumPy array with a couple of values. We have another NumPy array with another couple of values, right? But one thing you have to take a notice, it says 10, 20, 30, 40, 50. The next one is starting with 50 as well, right? Now let's take a look at the output first to understand what's going on. Take a look at this. It says 10, 20, 30, 40, 50, and eventually again it's 50. You have to be very careful. Every time you might try to do this, you're like, hey, if there's 52 times, there's a good chance that this might not be there. But no, we are not dealing with a set. We are trying to deal with arrays, right, ladies and gentlemen? It can get confusing even though it seems simple, but then the entire logic, the heart of the logic stands, it's here. np.vstack of n1, n2. n1 is the first array, n2 is the second array, right? Fantastic. That's question number 9. Let's take a look at question number 10. Question number 10 states, how is Python code interpreted, right? Now, of course, if you are at this level, if you're at this point of time where you're watching this particular video, this particular question, you should know that Python is an interpreted programming language and not a compiled programming language like C or C++, right? So whenever you go on to write a piece of Python code, let's just assume that it's 10 lines of code. This entire thing gets converted into its source code, from its source code basically to something called as IL. IL stands for intermediate language. Intermediate language is something that these intermediate language is something where it's not operating system dependent. Python works well on Windows, Python works well on Linux, Python works well on Raspberry Pi, Python works well regardless of the operating system. That is because its code basically gets converted into intermediate language, which is understood, in fact, passed through with all of these other operating systems as well. Once we have the intermediate language, later it gets converted into that particular machine's programming language, right? Machine language, again, you will know the code. Machines don't understand anything apart from 0 and 1, right? Now, this would be the answer to this particular question, but as we always do, let's just take one more step ahead. You can definitely go on to say that having the ability to use the interpreted language will definitely give you a lot of advantages in terms of how you can go on to work with the code, because every single line of code is executed one after the other, and eventually if there is a error on line number 7, everything until line number 6 will work absolutely fine. It's only at 7 that it gets stuck, right? So this is something you guys need to know about, right? Fantastic. Now, coming on to question number 11. Question number 11 states, how to remove spaces from a string in Python? Well, it seems like a very simple question, but you'll have to be very careful about the functions that you might use, right? Now, as you can see from the answer there, spaces can be removed by making use of two functions, the strip function and the replace function. Now, the strip function is basically used to remove the leading and the trailing white spaces, right? The white spaces that are ahead and the white spaces that are behind. But if you try to use the replace function will eventually go on to remove all the white spaces. So the question you must ask yourself, or in fact ask the interviewer, is saying, hey, okay, I know how to remove spaces from a string, but do you also want to remove the leading and the trailing white spaces, or do you want to remove every single white space that are present, right? Now let's just get back to our notebook so that we can understand it, right? It's just one simple line of code. The entire logic is only this much, and of course you can write this down to explain it to the interviewer, right? So we have one string 1 equal to great learning, great space learning, right? Now as soon as I run this piece of code, all we are trying to do is we're replacing space with what? With nothing. So eventually it just comes close. Now you can actually replace it with anything that you choose. If I just put A here, instead of the space, I'll just put great A learning. Of course, it doesn't make sense. The question says replace it and remove the spaces, right? Now let me quickly undo this, run this again, and you'll see that we have removed the white space. It's a very simple thing to remember. You have to replace space with nothing. So that's the syntax, right? Pretty simple, and at the same time pretty effective as well. Superb. Coming to question number 12, it states, explain the file processing modes that Python supports. Now, this is fantastic, right? Because with respect to file handling in Python, whenever you ask any questions in an interview, 80% of the time they usually try to expect a theoretical answer from you, because you'll have to create a file manually, you have to work on the logic, you have to build the file, open it, read it, write it, close it. You'll have to do all of these, and there's a good chance that you won't have time to do all this in an actual interview, right? So it's usually the theoretical questions that are asked. So the question asks how many, explain the modes that are present. First of all, you have to understand that there are 4 processing modes in Python, right? You can either work with the file in only a read-only mode, as in you can only read it, not write anything. Then of course, there's only something called write-only. Write-only mode will only work if you actually have the files already created. You will open it and eventually start writing. The read-write mode will eventually create a file even though you might not have, and it's going to work on it. It'll help you read, it'll help you write and perform the operations as well. But the last one, A, stands for append. Append basically means to attach at the end of something. So if you have one file and if you're trying to open another file and move all the contents of this file to the end of file 1, all you have to do is say append of 1 or 2, right? Because everything at the end of 1 will basically be the start of everything number 2. That's append in its most simple terms. But below that, there is a thing that says there are certain binary flags that you might have to follow. Whenever you're working with file operations or whenever you're working with file processing, it becomes super important for you to understand that there are certain binary flags which will help you understand what is going on with the file. You can set these flags and you can work with them as well, right? So again, it adds a good amount of value to talk about the modes as well and say, hey, we have the same names in the case of binary flags as well. Superb. With this, we can come to question number 13. It states, what is pickling and unpickling? This is going to be a question that has to be asked because this is considered super important, right? Now, what is pickling? Pickling is basically the process of us converting a Python object, in its entire hierarchy, right? The object hierarchy that is present into a byte stream. Now, why would you want to convert an object hierarchy into a byte stream? Well, to actually store it into a database, right? This operation, if you guys know how to work with data analysis and SQL, it's actually called as serialization. Now, we know what pickling is, but what is unpickling? As the name itself suggests, unpickling is literally the reverse of pickling, where we convert the byte stream back into its object hierarchy and we're done. Object hierarchy into a byte stream is pickling, but a byte stream into a object hierarchy converting back is nothing but unpickling, right? So make sure you're talking about serialization as well. There's another name for it. I think it's going to add a good amount of value if you say that, hey, pickling is also called serialization. That would impress the interviewer as well. Okay, fantastic. Coming to question number 14. Question number 14 states, how is memory managed in Python? Well, there's a question about memory management, right? Now, you have to understand that in Python, most of the data is stored in private heaps, right? It contains all the data structures that are needed to work with. It contains all the objects that we are going to be working with as well. Now, if there is a heap where you can do all of this, who is managing the heap? Well, the heap is actually managed by the interpreter itself. And in fact, if you have a curiosity saying, hey, can we look at this heap, access it and mess with it? The answer is no. The programmer will not get access to the private heap where memory is managed in the case of Python, right? And it's a good thing. You don't have to worry about any of these because Python, the memory manager that is present in Python does all the memory allocation, deallocation automatically as well. And of course, Python also has a garbage collector which eventually frees any sort of memory if it requires more space in the heap, right? So automatic allocation, there is a garbage collector to remove it as well. So you have nothing to break your head about in terms of memory management in Python. Python will do all of it for you, but if you're asked this particular question, you have to talk about the heap, you have to talk about who manages the heap, does the user have access to the heap, what does the Python memory manager do, and also talk about how everything from the data being input all the way to the data being output, as in thrown out or deleted, is handled by Python. Right? Super. Now, 15th question states, what is unit test in Python? Ladies and gentlemen, there's two ways you can be asked this question. This is unit test in a single word, and there is another unit test in two words, right? Now, unit test, unit space test is basically a methodology of how you can go on to test your piece of code or your application. But unit test as a single word is nothing but a very simple, again, you guessed it, a unit testing framework in Python, right? You can go on to talk about how you'll be sharing the startup of your code, how you'll be shutdowning the code, maybe in terms of tests, in terms of actually talking about how you can automate these tests and eventually have independence from these tests and the entire reporting framework, right? So this unit test basically splits out the entire part of unit testing and brings it to Python in a very easy way. It's a fantastic framework. If you are looking for software development jobs in the line of by using Python, this is something you'll have to know. And there are definitely multiple tools out there that will help you debug, but understanding that there is a framework which will do this for us is hugely advantageous, guys. All right, let's move on to the next question. Coming on to question number 16, it states, how do you delete a file in Python? Right now, usually when you ask the file processing modes or anything related to files, you'll have to talk about the modes, you'll have to talk about how you'll have to open the files, close the files and all of that. But once you not just talk about working with these files, there's a good chance the interviewer might say, okay, now that you're working with the file, I don't want the file anymore. So how do you delete it? Well, there is another fantastic library in Python called as the OS, right? I mean, eventually when you're working with all file related operations, you are going to be using that. So there's more than one way of how you can delete a file in Python. Take a look at the syntax here. os.remove a file name or os.unlink a file name. Right now, eventually in a perspective of a user, in a perspective of an application builder, both of these on the back end work in a pretty similar way. So whenever you ask this question, you can eventually give out a technical answer saying, hey, I can use this or I can use this, right? So instead of just saying to delete it, I want to use os.remove, try to think of something else. Try to think of more than one way of how you can attack the problem and solve it at the same time. Fantastic. With this, let's move on to the 17th question. The 17th question states, how do you create an empty class in Python? Why would you want to create an empty class will be the first question that might come into your head as soon as you read this particular question, right? Basically, it's simple, guys. To go on to create an empty class, we'll have to use the pass command, right? There's a command called pass. Now, whenever we define an object, whenever we define a class object, if you don't want to use it, just have the pass command there, and none of that will be used, right? So a pass command is nothing but a statement. Whenever you say pass, even in real life, when you say pass, it's similar. Like, it's like, I don't want to do something, I pass it on. Similarly, you're telling Python, hey, pass on this piece of code, don't execute it, just move on from there. Now, that is one thing that you'll have to understand, is that we already checked this out, in fact, even practically as well. Again, if you're at this point of time where you do not know how to create an empty class, or if you do not know how to work with the pass statement, I suggest you head back and take a look at the beginner section once. Right? Superb. Coming on to question number 18. Question number 18 states, what are Python decorators? Interesting. What are decorators? Are they used to decorate? Well, I'm just messing with you, right? In fact, they are. But what you have to answer when the interviewer asks you this, is say that decorators are nothing but functions which will take in another function as an argument, right? So you have the first function and you're sending in a second function as an argument. But all we are trying to do is we're trying to just send it as an argument rather than change the entire functionality of the first function that you eventually sent it to, right? So this is where you can go on to use a function, bring in values from other functions, and dynamically start working with it without breaking your head or without you having to change the base function itself. Right now, I understand that this can get a little confusing, so let's actually quickly take a look at this practically. Right now, I'll have to zoom out a little bit here. Now you can see we have a function here, it's called as smart divide, but with respect to smart divide, you can see that we are sending in a function as a parameter, right? Now here all we are trying to do is have a function which will basically give us how we can go on to divide some values, guys. Here is the entire logic for divide. Of course, to divide two numbers, you have to pass two parameters, a comma b, and all we are trying to do is we're printing a divided by b, right? Now as soon as I go on to run this piece of code, we have called the particular function here. We have called this function here. Right now we're saying divide 1 comma 0. It says, hey, make sure that the denominator is not 0, right? This entire value got passed into this function, and this is the statement that is being printed. Even though the code lies in another function, you can see that we've passed it to this particular function to have this output, right? Take a second to take a look at the code, and eventually it's a very simple piece of code that you'll understand, right? We're trying to return the function of a comma b, and we're trying to return the inner aspect of it, because this is the entire function that we are this is the thing that will give us the answer, right? Superb, guys. Now with this, we can take a look at the 19th question. The 19th question states, what does early binding mean? That's interesting. What is the meaning of early binding, right? Now, if you guys have been very familiar working with object-oriented programming structures, OOPS as it's called, you'll have to know that early binding is used there a lot, right? Early binding is, as the name itself suggests, even before we are trying to work on executing the program, even before it gets compiled or worked on the entire value assignment. For example, if you say a equal to 3, in Python, when you run it and when the interpreter runs through it is only when it gets executed. But what if I want the value of a to be 3 even before my code is executed? That is where early binding comes into the picture. It will finish all of these assignments so that you will save a ton of time with respect to the program efficiency, with respect to you having to run that same a equal to 3 piece of code maybe a lot of times in the entire project, right? So guys, this is an important question. Wherever the answer lies in the question itself. So whenever you asked this particular question, talk a little bit about OOPS, talk about what early binding is, talk about why you would want to use it, talk about where you want to use it. All these basic W questions, what, where, why, and eventually even how as well, right? So depending on what the interviewer is expecting, I would suggest you guys take an approach as this to answer them. All right, fantastic. Now guys, let's talk about the 20th question. The 20th question is very interesting. Even though it might seem to be uncommon, you have to understand that if you go to a Python interview, there's a good chance that the interviewer might ask you if you're an experienced professional, saying, have you worked with any other programming language, or to what level of proficiency you have in Python, right? Now, there's a good chance you might have learned more than one programming language. For example, I can work with C, C++, C#, and Python, right? So So if I've ever been asked this question saying, hey, what is supported in Python but not in Java? They're asking about one very specific difference that makes Python what it is. And of course, the answer to this is multiple inheritance. Multiple inheritance is supported in Python, but multiple inheritance does not work in Java, right? Now, why would you even want multiple inheritance, and how does it work in Python that it doesn't work in Java? Well, the logic, because it's implemented, how the language is built, right? Python is built to make sure that it can help you in a lot of different ways. And of course, with respect to multiple inheritance, this feature itself will give you the ability to maximize any sort of efficiency you're trying to understand with respect to a program, right? So the simple answer is multiple inheritance. And if you're at this point of time, and if you do not know the answer to this question, or if you do not know what inheritance means as well, guys, please take a second to actually take a look at a couple of previous questions, and also make sure that you are very thorough with these concepts, right? Now, these 20 questions that we have gone on to discuss are some of the most important questions with respect to how you can work with if you are an experienced professional, right? Now, even though we checked out 50 questions for beginners, 20 questions completely made for experienced people, you do have to understand that even for beginners and advanced users and eventually experienced professional, everyone, every time you step into a Python interview, there are certain tricky questions that get asked, right? Now, it's very fair to think about questions such as pattern printing. Think about the question when the question is very simple to know, but as soon as you take a look at the answer, you'll be stunned to understand that it requires so much of thinking and logic to solve it, right? And all these questions are usually asked when you're in the interview itself. They'll be like, hey, I'll give you 5 minutes time, can you do this? Now, this is a very, very important section, guys. We'll be covering 30 questions, 30 questions here, and each one of them are slightly different to each other, and some of them are completely fundamentally different. So regardless of you guys being beginners or regardless of you guys being experienced professional, I highly suggest you take a look at this, because there are so many chances that these questions can be asked across a broad spectrum of not just Python, but even if you're trying to look into jobs like data science with Python, or be it data analysis with Python. If they want to understand your approach to Python, they can ask you all of these questions. It's not just data science or data analysis, even web development and a lot more, right? Now, instead of us having to jump back and forth, since all of these are programs, all we'll do is actually head to Google Colab, and we're going to stay here for the next 30 questions, right? Now, let me minimize the experienced users section out here. Now, guys, is one very important thing. As you already know, you will have access to this Jupyter notebook as well, so you can sit and work with it parallelly as you watch this video. So make sure you guys are doing that, right? Now, let me zoom out a little bit so that we can see the entire code, right? In fact, let's zoom in. It's just the import statements that are taking up a good amount of space. Now, let's go on to save some space here. Now, so we can scroll down, see the entire logic. Fantastic. All right, guys, look at the question. The question states, how do you implement a probability plot using NumPy and Matplotlib? Now, this is a very specific question. If you have mentioned that you have worked with NumPy, I am confident that all of you all have. There's a good chance you might have not worked on Matplotlib, but they want to test your ability of how well you can graph something out, right? Now, a probability plot is basically using random functions to eventually print one plot, wherein every time you execute it, since the data that you're providing it to be random, it will of course create random probability values and map it on a probability curve, right? Now, this is what the curve looks like as and when I run it once. Now, all of this is random, because what we're trying to do is we're trying to use random values in itself, right? If you had data to create this plot, fantastic. In this case, it was a random question that was asked, so eventually we'll have to create our own data. Now that you've taken a look at this output, let me run it again. Now, as soon as I run it again, you see that entire pattern got shifted. Why? Because every single value was randomized, it got changed, and we have new probability values that are present here, right? So guys, you have to be careful if you ask questions like this. Now, here is the code again. All we're trying to do is import NumPy. There's a fantastic library called PyLab. And of course, guys, you have to know about SciPy and Matplotlib, right? SciPy it's called Scientific Python. It's a fantastic library to work with. And eventually we have Matplotlib, wherein we're trying to import pyplot. Now matplotlib, pyplot, seaborn, all of these are super important data visualization libraries in Python. All right, fantastic. Let's move on to question number 2. Question number 2 states, given the sample dictionary, how would you update the value of apple from 10 to 100? Well, given the sample dictionary, how would you go on to update the value of apple? Right now, the apple value is 10. Apple 10, orange 20, banana 30, guava 40. Now what they want to do is take out this 10 and input 100. Right? It's a very simple thing. All you have to do is this. But no, you already have an input that you have to work with, right? It's pretty simple, guys. It's very straightforward at this moment of time. They will try to confuse you by maybe giving you a lot of these values or maybe changing the structure of how they have denoted this as well, right? It's only to make sure that you get tricked and you don't know the logic. You cannot figure out the logic, but fret not. All you have to do is fruit of apple. What's the column that you're trying to access the data of? It's 10. We don't want 10. What do we want? We want 100, right? Just one line of code will eventually go on to change that. Now as soon as I run this, you can see that even though input is apple of 10, the output is apple of 100. This seems like a very easy question, but there are n number of chances where either you're a beginner who can mess up the logic and not understand, okay, how can we do this? Because again, if you just wanted it in real time, all you would do is change the input itself, but the input is fixed, the output is changing. So make sure you guys are paying attention there. Right? Fantastic. Coming on to the third tricky question. It states, how do you find the common elements that are present in two given sets? Okay, we're talking about sets. What is the most important thing that you have to understand about a set? Every single element is basically unique, right? Now, if I give 1, 2, 3, 4, 5, 6, and if I have another 6, S1 is a set which just has 6 unique values. Even though you see 7 right now, it doesn't care about any repeated values. You can have any number of repeated values, they're all ignored, right? So we have two sets, 1, 2, 3, 4, 5, 6. We have a second set, 5, 6, 7, 8, 9. Take special attention here. It says 5, 6. These are already repeated here, right? Now, as soon as you go on to intersect using the S1.intersection, what are we trying to find out? The common elements that are present here. The common elements that are present here are what? 5, 6 and 5, 6. Do not get confused of how a set works because that's what I just mentioned here. But the question is asking the common elements in two sets, not a single set, right? In that case, the intersection function works beautifully well and you will see the common elements. I'm sure we would have learned all of this back in our school or in our college, right? Intersection, union, all of these functions. All right, guys, superb. Coming on to the fourth question now. The fourth question states, implement the logic to check if a number is a palindrome or not. Now guys, if you are a fresher or if you have somewhere around 1 or less than 2 years of experience, this question has to be the question that usually get asked. In fact, we have multiple questions. All the 30 questions that we're going to discuss right now are super important for both beginners and experienced people. Well, how do you know that a number is a palindrome or not? Now, let me just hit enter because I want to actually type in a bit of comments for you guys right now. Now, is 10 a palindrome? Well, 10 is not a palindrome because if you reverse 10, you get 0 and 1. 0 and 1 is not the same as 10. But what about 121? 121, even though you write it backwards, is still 121, right? That is basically what a palindrome is, guys. When you reverse it, it has to remain the same. Now, this entire reverse logic, again, is super common, super popular. If you're at this point of time, you guys should know this logic. If you do not know, pay attention. All we're trying to do is assign a value of n to temp. We have rev equal to 0, rev talk about reverse, and we are running a while loop. While n is greater than 0, first of all, find the modulus of the number with respect to 10. We're trying to cut out the unit digits and we're trying to remove the place value. Now, when I write 121, it's not just 121, it's 121, right? To make sure that we remove all of these place values and to make sure that we have the reverse of it. First of all, this entire thing, guys, is nothing but reversing the number. What you do after reversing is check it with respect to the original. You have the original, you have reversed it, compare. If it's the same, done, it's a palindrome. If it's not same, it's not a palindrome. That is literally the logic, guys. 4 or 5 lines of logic, but a fantastic program. Let's just enter 10. It's going to say 10 is not a palindrome. Of course, it's not. Let me run it again. Now, let's try a really complex number, 13331. Or let's have this number, right? 213331 As soon as I go on to run this number is a palindrome. Why? No matter what side you write it from, it's going to be the exact same value, right? First of all, we're removing the place values, we're reversing it, and we're comparing a reverse operation to the original one, and we are done. Superb, guys. Now, coming on to the fifth question. Now, for a couple of questions from now, we'll be discussing pattern questions, guys. Pattern questions are absolutely asked. I don't want to say that there is a high probability of being asked. I know for sure that these questions get asked in most of these places, right? So be it startups, be it multinational corporations, these are very common standard questions that they're going to ask. So if you know how to tackle this, well, you're in good hands to land a fantastic job. Look at the pattern. What is the pattern trying to say? If you take a look at it in the column aspect, it says 1, 2, 3, 4, 5. The next one, there is absolutely nothing. We're starting from 2, 3, 4, 5. Again, 1 reduced, 3, 4, 5. Another dimensional reduced, 4, 5. Another one which just prints out 5. Now how can we go on to think about the logic? Well, we have two loops here. One is to control the range of the data. The other one is to control the movement of the data in itself, right? So you can see that input in range of 6. Now, why are we taking this to be 6? Well, all we are trying to do is understand from the range from 1 to 5, right? We want 1 all the way to 5. For I in range of input number, well, basically it's the input number here. All you're trying to do is print it, give out one space in the middle. And once you do this once, you will have 1. Next, you'll move on to the next line. You'll print 2, 2. Once you move on to the next line, 3, 3, 3. So the program is executing this in a row-wise manner. 1, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 5. Similarly, let's go on to run this program and you will find the same output, right? The execution is happening row-wise, but you can go on to understand it column-wise as well. And again, with these tricky questions, you might be asked for more than one way to actually solve the same problem, right? So make sure you're paying attention there as well. Now, this was fun. All we had to do is print the numbers. But what instead of numbers, there's a simpler question, maybe for a beginner, that says, hey, I have a couple of hashtags that I wanted printed with this left justified triangle, right? So it's always 1, 2, 3, 4, 5, 6, 7 elements in each and every row that I just mentioned, right? All you have to do is create a function called as pattern print. First of all, we're going to be starting from 0 because the first time we want a count and a print, we just want one hashtag there. What are we doing? If we printed this once, have a tracker or a flag there to ensure that you're telling Python, hey, if this was printed once, add 1 to it and print it that many times. If this was printed 2, add 1 to it and print it these many times. That's it's 1. Python knows it's printed it 1 time. Next, it's like, hey, I have to print it 2 times. Next, Python is like, I have to print it 3 times. And that is it, right? Of course, they've asked you for 1, 2, 3, 4, 5 rows. That's the reason we'll be sending the value of n to be 5. Now, let me go on to run this piece of code and you can see that it is there. But what if you want maybe 6 rows instead of 5? Well, big deal. Just send the value of 6 to the function and it will go on to print it using the same logic, right? All right, let me just turn this back to 5 so that you guys have the correct notebook with respect to the question. Superb. We have 5 rows. We have printed the hashtag. This one is actually a bit simpler compared to changing numbers or moving with respect to digits, ASCII values, all of that. All you're trying to do is print a hash. Eventually, we don't have any spaces here because the input does not have any spaces. In fact, if you want spaces, just put a space here. Go on to hit print, and you have beautiful looking white spaces in between as well. Simple, right? Well, let's jump back to take a look at more numbers. This time we're not taking a look at 1, 2, 2, 3, 3, 3, 4, 4, 4. We're trying to have all the columns as 0, next columns as 1, next columns as 2, next columns as 3, 4. But we're trying to reduce one dimension every single time we go on to do this, right? So take a look at the pattern, write down the pattern and see if you can build all the logic on your own. Guys, any of these tricky questions that we are trying to discuss, I want you guys to pause the video wherever you find it fair. Pause it, try to write the logic on your own and later compare it with what I'm teaching you guys. Or in fact, if you find another method to achieve the same thing, you can do it. There are many methods of how you can solve this particular problem, right? But it's very important that you think of it first rather than just taking a look at the output and saying, I got it, right? It can get very confusing during the interview as well. Now here again, we'll be considering 2 loops. We have the outer loop here. This outer loop completely handles the number of rows that we'll have to print, right? How How do you know that you're going to print? We can understand it as humans in a columnar fashion, but Python looks at it as rows. So how many rows do we need? 1, 2, 3, 4, 5. So basically the number that we are going to have to input here is 5, right? That is the outer loop that discusses the number of rows. Now we need to print the actual numbers after we understand how many numbers we have to print. That is where this comes into the picture. The inner loop talks about the logic wherein you just find a number, add 1 to it and just print it out. If it's 0 in the first row, you're just jumping directly to the next one. The next line, as soon as you see 0, you'll have to add 1 to it and print that element. Again, jump 0 plus 0, 1 and again 2. Right, so you're basically jumping one line and just attaching one more element there. You'll have to do it in order, and this simple loop is going to do this. Right, now let me remove a couple of spaces here so that you guys can look at this better. This is the entire logic, guys. Now that I've just hit the play button on this piece of code, it says how many rows do you want in your pattern. Now how many rows are they expecting? 1, 2, 3, 4, 5 rows. All I'm going to say is, hey, give me 5 rows. And as soon as I hit enter and scroll, you'll see this, right? 0, 0, 1, 0, 1, 2, 0, 1, 2, 3, 0, 1, 2, 3, 4. Right, guys, I hope we are clear with these 3 pattern questions that we discussed, because the next pattern question that we're about to discuss talks about the Pascal's triangle pattern. Pascal's pattern, factorial, reversing a number, all of these are really common questions that get asked. So you have to prep for this and you have to know this by heart, right? Well, what is the Pascal's triangle? The Pascal's triangle basically gives you an output that looks like this, guys. You can see the comment that has been made here, right? So, you have to understand how the variation in terms of permutation and combination works, because here for a Pascal triangle, the values are 0C0 and 1C0, 1C1. We jump to the next line, 2C0, 2C1, 2C2, jump to the next line, 3C0, 3C1, 3C2, 3C3, jump to the next line, 4C0, 1, 2, 3, 4. Again, for 5, it's 5C0, 5C1, 5C2, 5C3, 5C4, 5C5, and so on, right? This is the pattern that we want to print. But instead of printing 1C1, we have a formula for NCR, right? It's n factorial by n minus r factorial into r factorial. This is a very important formula for understanding the combinations aspect when you're learning permutation and combination. It's a very simple thing, guys. We're trying to import the math function. From the math function, we're trying to import factorial, because all of these things, instead of manually finding the factorial, we have a function that will do it for us easily, right? In our case, x is basically n, y is basically r. It's basically n factorial by n minus r factorial into r factorial, right? Let me go on to run this piece of code, and as you can see, it's going to give you an output which looks like an actual triangle. This is what? This is 0C0. What is this? 1C0. What is this? 1C1. 2C0. 2C, anything, NC0 is always 1, right? That's the reason all the first columns is going to be the same, but all the last values is also the same. What's with that? Well, 0C0 is 0, 1C1 is, 0C0 is 1, 1C1 is 1, 2C2 is 1, 3C2 is 1. Now, how am I saying all of these? Well, I know the concept by heart, and if you just run the values by calculating the factorial, this is the exact output that you're going to get, right? So printing the pattern should not be of any confusion, but the logic that you put inside the pattern is happening in one particular line, guys. Again, the outer loop talks about how you're traversing around the triangle, but the inner loop talks about what exactly it is that you are putting in this particular loop, right? So there's a very important question, guys. Make sure you are acing this when you are asked. Now, with that, coming to the next question, the 9th question. Here we don't have hashtags. Here we don't have numbers. We don't have anything else. We have A, B, C, D. Now, A, B, C, D are these characters. Of course, you already know this. Now, how do you go on to print a character and make Python understand how to print capital A, capital B, capital C? Well, Python understands characters and so in terms of a value called as the ASCII value, right? So all we have to do is find out the ASCII value for this, keep incrementing it everywhere, and just like the number solution 0, 1, 1, 2, 2, 2, 3, 3, 3, 4, 3, 3, 3, 4, 4, 4, 4, It's the same logic there, but instead of passing a number, we are trying to just pass the ASCII value, and once the ASCII equivalent is printed, it's nothing but A. Now the capital A, the ASCII value for capital A is 65, capital B is 66, capital C is 67, so on, right? There's an entire list that you can have. So all they're trying to do is ask for 4 rows, and again the outer loop always handles how many total rows that you want. This number is the magic number. The input loop, however, basically talks about how many columns that you want here. Now, how many columns are we expecting here again? Of course, since this is a left justified triangle, if you have 5 rows, you'll have 5 columns as well, right? And here is where the magic in terms of having the ASCII equivalent happens. You input 1, you input 2, you input 3, or you give any sort of character to it, you will have the ASCII value. So we have to convert the given character into ASCII, convert the ASCII back into the number, just print it out. We want 4 rows of ABCD here. So as soon as I go on to print this piece of code, it says enter number of rows. Let's just put in 4. As soon as I hit 4, it should go on to print A, B, B, C, 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 D, 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 right? This lines eventually, you'll have to increment it because we want to understand that there are more rows, right? We're talking about the inner loop where we're trying to move around the triangle. So whenever you guys are executing this alongside me, take a second to understand how not only the flow of the for loop works, but how the inner loop also talks with the outer loop, right, guys? That's a very, very important thing. Fantastic. We have printed this pattern. Now, there's a very good chance if they're asking you a lot of pattern questions on characters, they're going to say, hey, okay, so why don't you print us the entire alphabet in this particular order? A, B, C, D, E, F, G, H, I, J. So basically for every row, there is one increment in terms of how many numbers can go. First row, 1. Second row, 2 digits. Third row, 3 digits or 3 characters. Fourth row, 4 characters. Fifth row, 5 characters, and so on, right? Now this makes our job very easy. We're doing the same thing. We're converting the number equal to 65 because this is the ASCII value. Later we're sending it to the program to say, hey, whatever is the value or whatever is the digit or the character that has ASCII 65, print that for us. Similarly, the outer loop talks about the number of rows. The inner loop talks about how you can, how the values actually change into these particular ASCIIs, right? This is where we can doing the ASCII value conversions, and this is where the ASCII value conversions happening. Sorry, and this is where we are trying to implement a jumping and increment every single time. Now, how many rows have they asked, guys? 1, 2, 3, 4, 5, 6. Let me go on to print, let me go on to run this, and let me just type in 6. We will have the output to our particular answer. But since we are running ASCII values, you have to understand that, what happens if I input 10? Now, there won't be so many ABCDs to put there, right? Look at this. Z ended pretty much even before it came to a point where it could end it in the triangle itself. But after that, whatever is the ASCII value of capital Z, the next ASCII value is a left bracket, all of these operations that are there. You have to understand that capital A's ASCII value is extremely different from the lowercase ASCII value. That's how the computer understands the difference between a capital A and a lower a, right? So even if you have to do it for 10, all you have to do is input 10 and finish it, guys. Now let me go on to input 6 again, and we will have the required output. Now guys, make sure you're taking it slow, pause the video, watch out for how I'm explaining in terms of what each of these loops does, and work along with it side by side as well. Alright, superb. Now coming on to the 11th question. The 11th question says, if you have a dictionary like this, they have already given you the dictionary. This says K1 of 10, K2 is 20, K3 is 30. Okay, this is a dictionary. What do I do with the dictionary? The question is, how would you increment the values of all the keys? We're not trying to use the replace function to replace one value, nor can we use the replace function 100 times to do this manually. So how do we increment all of these, right? So it's a very simple thing. Just take the same dictionary, make sure you are running a loop, because a looping operation, since it's a common operation that's going for all the values that we're trying to increment. Now what are we trying to increment? They're asking increment the values of the keys, right? Of the keys. We want to make sure our key value will go up 1. So all I'm trying to do is I'm trying to take d1.keys in a function. For every I that is present there, just add one more. Now as soon as I go on to print d1.values, you'll see that it should say 11, 21 and 31 instead of 10, 20 and 30. What if I want to add a 10 to it instead of 1? It's a simple change of logic there. Just run it again and you can see 10 got added, right? Instead of 10 it's 20, instead of 20 it's 30, instead of 40, instead of 30 it is 40, right? Simple, guys. It's a very simple piece of code, but whenever you ask this in the interview at that moment of time, there's a good chance you might stumble upon something in this logic is not right. You're not able to figure out how to print it, or you're not figuring out how to work with the looping statement as well, right? Now I'm sure this will give you a good amount of clarity to go about doing that. Alright guys, coming to the 12th question. The 12th question states print random numbers using the random library. Well, you can do it two ways. One, you can just print any number that you want from the library using this tiny piece of code, but they can also say ask you a question saying, hey, I want to print random numbers but in a specified range. So let's just say that they want to print all random numbers between 10 and 20, right? Now you can go on to hit play, as you can see here, any number of times, and every time I do it, the first number is going to be a value between 0.0 and 1, and the second value, where we're using the randint function, we have the range that gets specified here. So everything from 10 to 20, including 20, that's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All of these will be printed in a random order. There is no order to this. Every time I go on to run this, it will just print out one random value, as you can see. Right? Fantastic, guys. Now moving on to the 13th question. The 13th question says denote the usage of args and kw arguments in Python. Args, it usually starts with the star args and double star kw args, right? Like just like this, the function arguments here. Now, what does args give us that kw arguments does not give us? Well, first of all, you have to understand that if you have any unnamed arguments, your args is going to pick it up. If you want any named argument, your kw args is going to pick it up, right? Take a look at this. I have passed in three parameters to this particular function called func1, and first of all, we have two values which don't have any sort of names associated with that, but third one has my name. My name is Anirudh, right? Now this is going to go and be picked up by kw args, while these two will be picked with arguments. So if I'm just printing the unnamed arguments, I'm going to have an output of 1, hello. But if I also want the named arguments, it's going to of course print Anirudh as well. Simple, straightforward, yet you can be pretty much confused if you do not know that you have to pass a named argument for kw args to work, right? Now if you miss this particular thing, this particular line, you will still get the output correct for args. This will just be put into args and you'll be breaking your head about why it's not kw args. It's not kw args because there is no name associated with it. Make sure you're compulsorily giving a name there as well, right? Superb. Now coming on to the 14th question. The 14th question talks about a beautiful copy operation in Python which can get very confusing. It's called as the shallow copy in Python. For the people who do not know, there are two types of copying that you can do in Python. There's something called shallow copy, there's something called deep copy. Deep copy basically allocates completely new memory, copies it from one place, keeps it in the second one, and the first one remains untouched, right? That is you just taking one banana, eventually making two more bananas out of it and not touching the main banana. The one banana is going to still remain there, right? Now here we have one list, the first list with 5 elements, 1, 2, 3, 4, 5, and all I'm trying to do is second list equal to first list. So I'm copying everything that's present in the first list to the second list. But then I'm doing one more operation here. I'm trying to append E to just the second list, right? So as of the output should, now that we're printing first list and second list, the output should be 1, 2, 3, 4, 5. Next line, 1, 2, 3, 4, 5, 6, because we are adding 6 to the second list. Will that be the output? Absolutely not. We're not doing a deep copy, we're doing a shallow copy. Since the second one is referring to the same address of where first underscore list is, the second you change the second list, the first list's value also gets changed. There are many advantages of why you would want to do this, but mostly it's tiny bit of disadvantages which can get eventually confusing. You'll be be breaking your head about why this is happening. I haven't attached 6 to the first list. It is happening because it's not your fault. The memory allocator in Python is basically taking the second list instead of creating a new memory allocation. Unless you want it, it'll be using the same one, and eventually it'll attach it to the first one. Because regardless of you printing second list, regardless of you printing first list, the changes happen in both because both of them are in the same memory location, guys. It's as simple as that. Right? Superb. Now, coming on to the 15th question, guys. The 15th question states, what will be the output of the following piece of code? Now, let me zoom in a little so that you guys can see this better. Now, ladies and gentlemen, even before I hit execute, and I'm very sure even before you hit execute on your notebook, try to guess, try to see what they're asking about. A of -1. A of -1 says, hey, start indexing everything from the last. The next one, the hyphen -4 states move 4 positions back. Okay, moving 4 positions back, I am at the 6th. The next one, which also says -1, is basically saying take single steps to move, right? Instead of going from 9 to 7 to 5, instead of jumping 2 at a time, just jump 1 at a time in the reverse order. Now, as soon as I run this, the output that I'm supposed to have should be 9, 8, and 7, right? Because this is -1. We're trying to go to the last one. Print the last one, jump 1 step behind, print the second last, jump 1, print the third last, and you're done. You might be a person who's saying, hey, it's -4. Should we not have 6 also to be printed? See, it's -1, -2, -3, -4. But when we're using a range function, everything between this and excluding this is printed, right? If you also want 6 to be printed, all you have to do is change this to -5. As soon as you hit -5, everything until 6 is printed, but it traverses through 5, but 5 is not printed, right? So this is very important question, guys. So it can be something as simple as this. If you just hit -2, you'll basically get 9 and 7 as the output. You're just skipping it twice, right? So you can be asked any sort of questions around this. So make sure you're very, very confident with even the most simplest questions such as this. Alright, guys, now to talk about the 16th question. The 16th question states, how do you print the ASCII values of a given character? Now, we already discussed the section where we're taking a look at a lot of ASCII characters when we are printing the patterns out, but you have to understand that they're just saying, hey, I'm going to give you a value, just print me the ASCII for it, right? Now, there are two functions. CHR basically converts an integer to back to its character, but the ORD function basically takes the character and converts it eventually to a number, right? Now, as soon as I hit play, it'll just print me the ASCII value of small a, which is 97. Now, what was the ASCII value for capital A that we just discussed, right? It is 65, right? As soon as I go on to print it, it says 65. Now, it can be anything. They can ask you the ASCII value maybe for capital Z. Well, of course, any value that you pass on is pretty simple. You can also implement the logic where you're just putting in this entire thing in an infinite loop and just saying, hey, input a value, I'll print out the ASCII. So as in when you start punching in the ASCII values, the output is straight up. As in when you start punching in the characters, the output is ASCII values, right? 16 is very straightforward. All the logic just lies with this. The entire working, the answer to this entire question is only here, but to just make it a little beautiful to look at, we're just doing this, right? Fantastic, guys. Now the next question, the 17th question states, what is the easiest way to shuffle a list? Shuffling a list. Why would you want to shuffle a list? Well, it might always be a case wherein you want to quickly randomize all the elements that are present in your list, right? Instead of you importing the random function, using the random.random, creating your random values, or in fact using the values that are already present, we'll still be using the shuffle part of the random function. But here we have one list. It says, you'll never walk alone. This is basically the slogan of my favorite football club. If you do not know the slogan for the football club, it's basically Liverpool, right? So now as soon as we hit shuffle off this particular list, it will give me one random output every time. See, alone, never, walk, you'll. It basically reverse the entire thing. Now it's not done on purpose, it's random. As soon as I run this again, it says walk alone, never you'll. right? Let me run this again. It'll say you'll walk never alone, right? You can see that it's shifting around and moving it. So if ever you think that there is some sort of bias in the data that's present, and if you can jumble it around and still work with the logic, you can remove that random bias. It's called as random bias, guys. So you can remove that to work with it. So the simple, again, the logic is just one line of code, but when you're in an interview, you really should know this as well, right? Superb. Coming on to the 18th question. The 18th question states, how does floor division work in Python? Absolutely fantastic, guys. Now I want all of you all to pick up your calculators because we're going to be doing some calculation here, right? You can in fact do all of this manually as well. I'll ask you math questions. Don't look at the syntax there. What is 5 divided by 2? 2.5. What is minus 7 divided by 2? Minus 3.5. What is 7 by 2? 3.5. What is minus 7 by 2? Again, minus 3.5, right? Fantastic. Now all of this is good, but there is a difference between just division and floor division. Floor division basically just removes the floating point number and just crashes the entire value to the next lowest value, right? Now as soon as I run this, the output should be 2, minus 4, 3 and minus 4. Yes. Now why is this? This you would have understood, right? 5 by 2 is 2.5. Just throw the 0.5 away. You get 2, right? Superb. That's correct. Now, take a look at 7.0 by 2. This is also correct, right? 7 by 2 is basically 3.5. Take the 0.5, kick it out, you get 3 and eventually you print this. Since it's a floating input, you have a floating output. Python is very intelligent to understand since it's a strongly typed programming language, right? Fantastic. But these two lines where I'm putting in a hashtag right now, the comment, this is where something is missing. Minus 7 by 2 should give me minus 3.5. If I check out the 0.5, my answer should be minus 3 and not minus 5. Correct? This is a question that the interviewer is going to ask you to trick you. The answer is no, because if you take a look at the number line and if you have minus 3.5, what is the lower value compared to minus 3.5? It is a value which is still lower than minus 3, which is what? Minus 4. It cannot be a value higher. We are trying to use what division? Floor division. We are trying to floor it to the lowest values, right? That is the reason why this gives you minus 4 instead of minus 3. Be very, very careful at this. The interviewers are going to try to trick you to say, as soon as you you say that, hey, minus 7 by 2 gives me minus 3.5, they'll be like, are you sure? Now the next thing you might say is, okay, it might give me minus 4. Then also they'll be like, no, don't you think it's minus 3? They can confuse you a lot, guys. So be very careful with the 18th question. But now that you know how to tackle it, I am confident that you guys will handle it well, right? Take a look at question number 19. Question number 19 states, denote the usage of pass by value and pass by reference. It's also called as call by value or call by reference. It's a simple concept, guys. Whenever you're trying to change the scope of a variable, whenever you want to pass the scope of a variable, you just want the changes to happen in the new memory allocation rather than the old one, right? Just like shallow copy and deep copy. If you call something by its value, the memory address remains the same. So all you're going to get is the value that you asked for. If you pass it by reference, what Python is doing in the backend is it's sending the memory address of where the data is stored. So if you make any sort of changes to the memory, the memory address there, the data that is stored in the memory address, it will change everywhere regardless of the scope of the variable. So call by value will only change it in that scope. Call by reference is where you're just sending in the address saying, hey, you do whatever you want with this address. You can copy, delete, move, change. In that case, the changes will be reflected everywhere, right? Let's take a look at this. We have a very simple array, 3 elements, 1, 2, 3. And if I just go on to print it out, it's call by value, right? Call by value is the same. It's going to still give me 1, 2, 3. But when we run call by reference, I am trying to take it to this particular function. I'm inputting the array value there and I'm appending one more element, 4. Now you have to understand that we just passed the memory location to 4 and eventually it understood that saying, hey, there is 1, 2, 3 already, let me just attach on to the same thing. It figured out that there is 1, 2, 3 not by the value themselves or the array itself, but by the memory location where the elements of this array is stored, right? Again, call by value, call by reference are really basic stuff that you must know at this moment of time, guys. If you do not know, it's okay, pause the video. There's many articles wherein you can figure out what call by value are, call by references, but as I just mentioned, it is literally that. So even if you are asked a theoretical question, you can literally state the answer that I just stated, right? Fantastic. Now this has to be a question that gets asked every single time, ladies and gentlemen. It says, hello world, double colon of -1. Double colon of single colon of -1 will basically give you the output of the last character. But you look at this, right? We're just moving on to the last one and just printing everything there. Now, what if there is a double colon here that says double colon of -1? This is a very simple shortcut to take a string, reverse the entire string and print it out. Look at this. Hello world became completely reversed, as you can see, right? So basically -1 is saying traverse everything from the last instead of the first, right? If you start writing everything from the last to the first, of course it's going to reverse itself, and that is the output that we see. If you are a beginner Python user attending a Python interview, there is a very good chance you'll be asked these indices tricky questions, right? As we discussed previously as well, we took a look at multiple questions there. Make sure you are understanding the heart of the logic here. Right? Superb, guys. Let's discuss the last 10 questions that I have for you today. Now, 21st question states, what is the output of this operation on a list? List multiplied by 2. Now, this is a super tricky question. This is where a lot of people go wrong that I have seen personally as well. Now, I have a list with 5 elements, 1, 2, 3, 4, 5. As soon as I multiply it with 2, what do you think is going to happen? 1 becomes 2, 2 becomes 4, 3 becomes 6, 4 becomes what? 8, 5 becomes 10. Correct? Answer is absolutely not, because the asterisk operation will copy that element into another. So instead of you guys getting 2, 4, 6, 8, 10, you're going to get 1, 2, 3, 4, 5, but twice this time, right? Now this is a very confusing output even to someone who has worked with Python previously. At the heat of the moment, if you're asked this question, you will just want to say that all the elements will get doubled. If it is into 3, there is a very good chance you can say, hey, we're just tripling it, right? Because this is a multiplication operation that we usually use. But do not be confused, guys. If you use this operation with respect to a list, all you're trying to do is replicate the elements once again. So if it is 1, 2, 3 instead of 1, 2, 3, 4, 5, what do you think is going to be the output? It's going to be 1, 2, 3, 1, 2, 3, right? Look at that. Fantastic, right? It's very simple, very confusing, a fantastic chance for the interviewers to trick you. Okay, coming on to the 22nd question. The 22nd question states, write the logic to check if the given number is an Armstrong number or not. Ladies and gentlemen, this is a question that has to be asked because they want to understand, the interviewer wants to understand if you know what an Armstrong number is. The second thing they want to know if you, of course, can work with the logic, if you can work with the syntax and all of that, right? Now, an Armstrong number is pretty simple, guys. Basically, what we're trying to find out is the cube of every single digit. Now, if I input 153 and if I want to find out if this is an Armstrong number or not, what is 5 cube? 5 5s are 25, 5s are 125. Correct? Simple. What is 3 cube? 3 into 3 is 9. 9 into 3 is what? 27, right? Now, all I did was take this digit, find its cube. Take the second digit, find the cube. Take the third digit, find the cube. As soon as I did this, just add all of these values. 125 plus 1 is 126. 126 plus 27 is 153. So no matter what number you provide, if all of those cubes add up to this number, it's called as the Armstrong number, guys. Now if I just put in 10, right? This logic is wonderful. What if we discussed not an Armstrong number? Not an Armstrong number, let's just take 10. Right? If 10 is your input, the first digit is what? Cube. Cube of 1 is what? 1 into 1 into 1 equal to 1. What is the cube of 0? 0 of cube is 0, right? Now, is 1 plus 0 equal to 10? No, 1 plus 0, even though 1 cube plus 0 cube is not equal to 10, it's only equal to 1. Hence, 10 is not an Armstrong number. Similarly, for 407, 4 cube plus 0 cube plus 7 cube is eventually going to give you an answer 403, right? Now that we understood what an Armstrong number is, this is the entire logic, guys. This is the pretty much the logic. All we're trying to do is take the input from the user. The user can input any number he or she wants while they input a positive number, right? You have to make sure that it's a positive number. While they input a positive number, all you're trying to do is trying to find the cube. As I told you, here also we are taking the place value, right? This is not 153, this is 153. So we are removing the place values, creating individual numbers out of there, cubing it and finding one sum. If your input number is equal to the sum of the cubes of all the individual digits, it is an Armstrong number, else it's not, right? It's very, very simple, but if you do not know what an Armstrong number is, you cannot attack this problem, right? First of all, let's input 10. 10 is not an Armstrong number. Now, as soon as I run this, it says 10 is not an Armstrong number. Fantastic. Let's run it again. This time, let's push the values 407. 407 is an Armstrong number. As soon as I run this and I come down, it says 407 is an Armstrong number, right? We understood what an Armstrong number is. We understood the logic that goes on to working with an Armstrong number, and we also figure out a way to print if its given number is an Armstrong number or not, right? If you were a person who just said, okay, so Armstrong number is done, which number next? Well, the next number that you'll have to take a look at is a perfect number. Now, what is a perfect number? We know what an Armstrong number is, but what is a perfect number? A perfect number is basically sum of the individual divisors of all of these values, right? To find out if 6 is a perfect number, what are all these digits that you can divide 6 with, right? 1 into 6 is 6, 2 into 3 is 6, 3 into 2 is 6 as well. So 1 plus 2 plus 3 gives you 6. The logic is simple, guys. So all you have to find out if this is a perfect number or not is take all the divisors out of it. Every number that gets divided, just add it on, you will get it, right? Now, if now that we've said that even 28 and 8128 are also perfect numbers, let's actually find out why 28 is a perfect number, right? Now, for 28, what is the logic that you think you should follow? Find out all the digits where 28 is divisible. It goes with 1, it goes with 2, it doesn't go with 3, it goes with 4, it doesn't go with 5, 6 doesn't go, guys, 6 table. Are you guys calculating? 6 4s are 24, it will not go, right? So 7 3s are 21, 7 4s are 28, right? Yes, 7 also works. Now 7 is done. Does it work with 8? I don't think so. Does it work with 9? No. 10, of course, no. 11, no. 12 now is 12 2s is what? 24. So no. Does 13 work? No. What is the next one that works? Well, it's 14. Everything excluding the number itself, right? Now, of course, even 28 into 1 is still 28, but the logic of a perfect number is to consider everything apart from this number, right? Now, let's add this. 14, 15, 16, 17, 18, 19, 20, 21. 21 plus 7 is 28, right? So, the individual sum of all of the digits, if you get the input digit back, simple, it's a perfect number, right? The logic again is very simple. Just break the number down, remove all its place values, consider each individual digit, sum it up. If your sum is equal to the input, tada, it's a perfect square, right? All you have to do is find the divisors. Look at this, look at the logic here. It says number mod I equal to 0. If it divides the number perfectly without any reminder, find all those ones and make sure that you're just printing it out at the end of the day, right? So let's just put in 6 and 28 now. As soon as I put in 6, it should say 6. Hang on, I have an error here. Now, let's just actually go on to track why this error is there. Okay, my bad. It doesn't know what capital number is, right? Because this doesn't stand for capital number. This stands for number input, right? As soon as I hit run again, it should work fine now, guys. Let me go on to hit 6. As soon as I hit 6, it says 6 is a perfect number. Let me run it again. Let's take a look at 28 now. 28, we already saw how it works perfectly, and we know that it's a perfect number. Okay, we checked out the logic logic for a perfect number, but let's understand maybe a non-perfect number, right? I'll just put in 3. Now, if 3 is not a perfect number, again, you can guess why, right? 3 is divisible by only 1 and 3. If you exclude 3, you only get 1. 1 is not equal to 3, hence it's not a perfect number. Again, the heart of the logic is just these lines, guys. You're using an iterator, you're trying to find it out you're trying to find out all the numbers wherein it divides it perfectly. Just add it up, compare it with respect to the input. If it's the same, it's perfect. If it's not, it is not perfect, right? We took a look at Armstrong number. We took a look at perfect number. The next thing we're going to take a look at is a strong number. Now, a strong number is similar to these other numbers that we just discussed, but here we're going to be considering factorials, the sum of factorials of every single number. If it is equal to your input, it is strong numbers, right? The sum of the factorials of individual inputs. That is what makes a strong number. Let's take an example. In fact, I have an example already on your screen here, guys. If we go on to put the input as 145, just split it into separate digits, 1, 4, and 5. Just find out 1 factorial, 4 factorial, 5 factorial. Add all these up. If it is equal to 145, it's a strong number, else it's not, right? All we're trying to do is take an input, copy it to a temporary variable. We have a while loop here. In fact, we have 2 while loops. One is to check out the structure, break it into individual digits. The next while loop is basically the entire heart of the logic, where we're not just trying to break the number, but we are also trying to find out if the factorials add up to the sum. And once we have the sum at hand, we're trying to see if this sum is equal to the input. Look at this. If sum equal to temp. Why temp? Because we have assigned the input number to be temp, right? We're just copying it and placing it there. Now that we understood this, let me run it. Let me go on to find out 145 first to see if the logic works. It says the given number is a strong number. So let's go on to type a number which is not a strong number, maybe 12. As soon as I go on to type 12, what is 1 factorial? 1. What is 2 factorial? 2. What is 1 plus 2? Is 3. It is not 12. That's the reason why this is not a strong number. I hope this is clear with all of you all. Right, guys? Superb. I know we are discussing a lot of patterns, a lot of number printing one after the other. You have to understand, even in an interview situation, there is a very good chance you can be asked one after the other with respect to different logic. So you have to be prepared on any front to attack and solve the problem, right? So that's the reason we are trying to give you guys all these top questions wherein you can easily use this and go on to ace your interviews, right? Fantastic. Coming on to the last 5 questions. In fact, the 6th question here, it says the 25th question states, write a program to find out the second largest number in a list. Absolutely fantastic. If you have ever given an SQL interview or a database interview, there's a very good chance this will be asked. There is a very easy way to find the maximum value. Just use the aggregation function max. It's going to give you the last value. But what they want here is not the max value, but the second largest value. Not the largest, the second largest, as in one previous from that. So if I have an input, let me just go on to type this out for you guys. If I have an input 1, 2, 3. Now what is the largest number here? 2. What is the second largest number here? What is the largest number? 3. What is the second largest number? 2. In fact, let me take a different example. 4, 5, 6, 7, 1000, right? What is the largest number? 1000. But what is the number that is less than 1000 but greater than 6? It has to be 7. Right? So this is how we try to find out the second largest one. Now quickly taking a look at the logic. First of all, we have a for loop. We're trying to find the range from 1 to the digit, including the last digit as well. Here we're trying to get an input from the user. All we're trying to do is attach whatever input we got to our list and sort it out. Once you attach the number that you get in a list and start sorting it out from the last element and just print the last but one element, this again is where all your logic is happening, right? So you're inputting the element, you're attaching whatever it is that you just inputted into the list as well. And not just that, you're also basically printing it out. While printing out the logic of the list is where the magic lies. Now, as soon as I run this, it'll say, how many elements do you want? Well, I just want to input 4 elements, let's just say. So I want to input 10. I want to input 20. I want to input 4000. I'm going to input like 6 lakhs or 60 lakhs or whatever that is, 60 lakhs, right? Now, 60 lakhs is the most maximum one. 1 before 60 lakhs is 4,000. So I have 4,000. Very simple logic. It's very easy to print the last one, but you're going to have to work on printing this last but one element, right, guys? It's very straightforward. At the same time, it is very vital that all of you all know about this. Right, superb. Coming on to the 26th question, it says, what is the logic to quickly swap the first and the last element in a list? Okay, wonderful. We know how to work with the list. We know how to reverse the list. We know how to find out the index of the last element, which is -1. We know the index of the first position, which is again 0. Python index is from 0. But what they are asking for is saying, find the first one, find the last one, change it out. Right? So this is where the swap logic, the heart of the swap logic is. First of all, we try to create a temporary list and just put the original list there. So it's the simple logic, guys. A equal to B, B equal to C, C equal to A. Right? You're eventually swapping the first and the last values, but the name here is just, instead of the characters that I just said, it's the list. As soon as I go on to print it, you'll see that this is our input list, our sample list, right? The input is 11, 20, 30, 40, 50, but the output is 50 and 11. You can see that these first digit and the last digit got swapped, right? In fact, there's a meme, there's a sticker on WhatsApp with Ajay Devgan or someone doing this, right? So that's what I can think of as soon as I saw this. Okay, guys, again, all you have to do is input a sample list, write the logic to copy it. A equal to B, B equal to C, C equal to A, and you are good to go. But here what we want to find out is to find out the maximum size, and 1 minus that. Well, instead of size, why are we doing size minus 1 is the question you're supposed to be asking right now. The answer to that is Python indexes everything from 0 instead of 1. So if you have a programming language which indexes from 1 rather than 0, you'll just say temp equal to sample list of 0, 0 equal to size equal to temp. We're saying size minus 1 because we're starting from 0 with respect to the index, right? It's all simple, straightforward questions as soon as you look at the answer. But as soon as the answer is hidden and just the question is shown to you, you can stumble upon it and take some time to think as well, right? So make sure that you guys are figuring this out easily as well. Fantastic. Now that we know how to swap the first and the last element, let's take a look at the 27th program, which states write a program to count the number of vowels present in an input string. First of all, what is the input string? The input string, since we're talking about vowels and consonant, it has to be characters, right? Now, Anirudh Rao is my name. This is the input string. But to make Python understand what the vowels are, we have to specify it, right? Capital A to capital E, A, E, I, O, U should be in the lowercase, should also be in the uppercase, right? Because if you just put it in caps, Python is of course treating lower cases very much differently to upper cases, because you saw the ASCII values are fundamentally different. So when I say that check for these, I am giving both the lower case and the upper case as well, right? And eventually we're just sending these both functions. In fact, this has to be input underscore string, right? We're just sending the string value, we're sending the vowel list into this to go on to compare and see if it works or not. Now, as soon as I hit enter, all the output that I should get is, first of all, it should tell me the length of number of vowels. So it's giving me the number of vowels that are present in Anirudh Rao, right? So it's A, 1, 2, 3, 4, 5. Correct? 5 different vowels. Now, what are the vowels that it caught? A from the capital I, capital A, I, U, A, O. A, O is from Rao and A, I, U is from Anirudh, right? And again, the heart of the logic is this one particular line, just to traverse with each and every single element, and you just being very careful about giving both lowercase and uppercase. It's just passing these values to a function, having it in a structured modular way to print it out, right, guys? It's fairly simple, at the same time fairly easy to get confused as well. So make sure you're paying a lot of attention there. Superb. Coming on to the 28th question. The 28th question states, how do you break a list into n chunks using Python? Now, n can be any number that I want. If I want to break this list into 10 chunks, I can do it. If I want to break it into 5 chunks, I can do it. Now, when I say chunks, let's see the output first and then work on the logic. You can see that this is the input, right? 1 to 13. Now, I want to break it into how many pieces? In this, basically that, how many pieces that I want to break it into? I want to break it into 4 pieces. You can see this, 1 piece, second, third, fourth. even though it does not have enough elements to do complete the last one, it still breaks it, right? Now let's make Python a little happy. Let's just put in 13, 14, 15 and 16 as well, right? Now if I'm breaking this into 4 lists, it's going to be equal elements in every single entity. Look at this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is 1, 13, 14, 15, 16 is 1 as well, right? Again, the logic is basically this, guys. All we're trying to do is find the input list. Now, what is this particular logic, right? We already learned this. Take a second to remember what this is. Once we create a simple nameless function for our logic, all we're trying to do is use the for loop and just traverse from 0 to the length of the input list and eventually break it down into what? Into n pieces for us, right? Pretty simple, guys. It's just a simple list operation that will tell you what is supposed to be done. What's the input? How many pieces do you want to break it? How do you break it? Print the broken output. That is it, right? 4 lines, four different things that these lines do. Fantastic, guys. Now coming on to the 29th and the 30th question, we're going to be discussing a bit of exception handling, right? Exception handling is again an exceptionally important part of Python as well. There are a lot of things with respect to the keywords that you'll be using in the exception handling part. Try is basically used to just put in all the code where you're trying to experiment to see if there's an exception that will occur. And except block stands for exception. If there is an exception, everything under this code segment will execute. And if your exception is not caught, as in the logic that you have put here is completely correct, this will not be executed, but else will be executed, right? Let me repeat that again. In your try block, if there is no exception, this entire block is skipped. If there is no exception, this is skipped and this is printed compulsorily. But if you do have an exception, it will come here, it will figure out there's an exception, quickly it will jump here to say that there is an exception. Let's in fact try it out. It's saying enter the first number. My first number is 10. It is saying enter the second number. Now I am a very intelligent boy. I'll put it to 0. 10 by 0 is not done. So as soon as it sees 10 by 0, it just came here, asked me for input, came here, asked me for input, figured out the logic, and it says the output is Z. But instead of it actually being able to print, there is an exception that is there inside the try block that will quickly jump to except block and print this message. You see, if except is printed, else is not printed. If else is printed, it means your logic is correct and there's no exception. Let's do it again. Enter the first number 10. I want to divide 10 by 2. Is it possible mathematically? Of course it is possible. So this entire block is not at all executed, but this is executed, right? Just take a look at this comment. This comment will basically tell you everything you need to know about what is executed, what is not executed, right? Fantastic, guys. Coming on to the last question now. The last question states, how does the finally block work in Python? Try, except, else, finally, right? We already know try. If we have to experiment something, just throw it in the try block and catch if there is an exception. We understood this. We understood the else as well. But the finally keyword, something you're really supposed to know about this is the fact that no matter what, either your exception is caught, your exception is uncaught because it's not present, no matter what, unlike the else loop, the else will only work if your exception is not, if this part of the code is not executed, else will run. If this is executed, else will not run. Finally is a good boy. Finally doesn't do all that. No matter what you try, no matter what exception you get, God bless, it will run finally, right? As soon as I go on to click this, we are basically dividing 5 by 0, floor division of 5 by 0. It says, hey, sorry, I cannot divide it. So try block got executed, except block got executed, finally block always gets executed, right? Look at the comment. It says executed regardless of exception occurrence. Either your exception is caught or uncaught, no matter what, this piece of code will always be executed, right? So guys, these are the important questions that we discussed. Now, of course, let me zoom out a little. We discussed 50 very important questions for beginners. We discussed somewhere around 20 very important questions for experienced users. And for both beginners and experienced, we discussed 30 different programs. That brings us to a total of 100 Python questions. Right now, all these 100 questions have the highest probability to be asked in this particular year and going ahead as well, guys. So make sure you guys are paying attention on that. All right, guys. Now that was a lot of important questions that we had to cover here. Right now, these questions, as I mentioned throughout this particular video, are really important going ahead for your Python interviews. Now, we've taken a lot of time to research all these questions to a very good amount of depth, to a good amount of detail, to make sure that at the end you guys have one video that you can refer for your Python interviews, right? So I hope you guys had fun watching this particular video. I really hope that you guys took a lot of learning away from this and you're going to use this to ace your Python interviews and land your dream jobs, right? Superb. On that note, guys, my name is Anirudh Rao. Thank you so much for watching. Have a fantastic day ahead and good luck for all your interviews ahead, right? I want to welcome all of you all watching this particular video with open arms into the Python developer community, right, guys? Okay, superb. Thank you so much for watching. See you.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleagues, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.